Good morning and happy 75th Independence Day of the Republic of India to each and everybody. As our country is embarking on Amrit Kal from today, India and the citizens of India vows to pledge to fulfill the dreams and aspiration of our great freedom fighters who fought against the British to gift us this great nation. On behalf of Apollonius Computational Business Solution, I express my thanks for attending the second International Independence Day webinar on Artificial Intelligence 2022 to each and everybody. Apollonius is a policy research, advisory, consulting, and training company based at Kolkata, India, with its core focus on artificial intelligence, data science, deep learning, and optimization engineering. We are trying to solve some of the key issues related to our country's supply chain management, agri-tech, and digital modernization. This year, our focus is introducing the students and AI enthusiasts to learn the high-impact futuristic areas of AI, both from research point of view as well as from the industry point of view. With our eminent speakers from IIT Kanpur, Buet Dhaka, and Experts Lab IBM, I believe that the upcoming 3 hours will be a great learning and interacting sessions for each and every one of us. I am glad to state that this year we have participants across the nation from our neighboring country, from the People's Republic of India to the People's Republic of Bangladesh. I am also extremely happy to announce that this year we have our distinguished speakers from India, United States, as well as from Bangladesh. So, to begin with this particular seminar on this August day, we shall stand for our national anthem first to pay our respect to the great nation India. So please join us on the national anthem of India. Jai Hind. So, good morning, Sri Mojumdar. Am I audible to you?
Yes, I can hear you.
Yeah. Thank you very much. To introduce yourself to our participants who are participating in this Vaipnia, I just like to introduce to all our fellow participants about Sri Shourabh Majumdar. Sri Shourabh Majumdar is an AI ML operational leader at IBM Experts Lab USA and also Open Group Distinguished Data Scientist. A brief bio. Shourabh is an Open Group Distinguished Data Scientist who is responsible for the technical thought leadership and strategy, technical vitality, and technical enablement in IBM's AI and data science area. Shourabh works with enterprise clients from AI strategy development to implementation and productionization, particularly on first of a kind projects. Shourabh has authored multiple books, blogs, and articles about artificial intelligence, data science, and big data. He regularly speaks at various industry conferences such as Open Data Science Conference, Spark Summit, IBM Think, and Global AI Conference. He is also an alumnus of IIT Kanpur. Today, he will going to give his keynote talk on AI governance. So, on behalf of Apollonius, we welcome you, sir, to deliver your keynote talk. Thank you very much.
Thank you, Shobha, and it is really my pleasure to be in this particular session. And thanks to every participant who has taken your time to join this session. I hope you all will find it um, at least, if not enlightening, at least something interesting, something fun, um, and hope this is something what you'd be able to use it in your further journey towards AI. So I personally, I'm not really aware of all you guys' background, and neither we have time to get into that detail right now. So please feel free to ask any questions in between if you have if you have some doubt, because this session is more around very uh, very much generic idea of governance of AI models. So it will help you to understand how to govern AI models in production. But there is some assumption that you guys have some understanding of few basic things. So anywhere if you have some doubt, so please feel free to ask me the question. Sounds good. Can we start?
Yes, sir.
Okay. So in this session, we essentially have basically I've divided it in three parts. In the first part, we'll try to uh, go in detail of the challenges and the requirements of AI governance. I think all of you here, you are interested about AI. That is the reason you are in this session. But at the same time, what is important also to know that AI is not just about creating some model and using it, right? There is a much bigger uh, bigger implications of using AI for any business problem. So we would we would try to get into some details of those challenges and the requirements. In the second part of this discussions, we'll get into the detail of the solution, how a AI governance solution can be developed, which can take care of those challenges and the requirements, the needs. And then in the third section, I will get into the detail of how typically the organizations are moving towards, I mean, what is their journey to create a AI governance solution. So in the very first section, I'll basically uh, like to make you all aware of the various regulatory needs of AI, or the models, AI models, which are used in um, for production purpose. Okay, just let me take a step back. I hope my slides are visible to everyone.
Yeah, it's visible. So yes, it's visible too. Yeah.
Okay, very good. So all the countries across the globe, they are coming out with AI related requirements, compliance requirements, um, and it is not just happening right now, today, or this year or last year. It is happening for last 10 years or more, where all the countries who are using AI in their business solution, they have their requirements set up at the compliance level. So if I take the example of United States, here back into 2011 itself, there was the requirement came as SR 1107, which talks about how to manage the uh, AI models for the financial risk. Then in 2021, the FTC, Federal Trade Commission, they came out with the guidance of AI. At the Europe level, you people must be aware of the general requirement of GDPR. Now, on top of that, there are also other guidelines came for AI development. Then European Commission has just standardized the requirements for Artificial Intelligence Act as latest as 2022. UK has various AI-related regulatory act. So all the countries, they are essentially putting some acts around regulatory requirements around what all should be done or cannot be done while creating and using AI models in production application. So what is a production application? A production application means, say, you have developed a AI model for fraud identification. Now that particular AI model is used, maybe the point of sales, the various stores of a retail company, right? Now every transaction which is passing through that retail point of sale store, it is essentially calling that AI model to figure out whether this transaction can be a fraudulent transaction or it is a proper transaction. It can be also through internet channel, right? Through shopping cart or the websites. So these are the business
Excuse me.
applications.
Just to stop you, the
Mhm.
slides are not actually changing. So if
Now,
you
I have
can,
not changed the slide yet. I'm right now in the regulatory compliance slide. Can you see
oh,
that?
regulatory compliance. No, it is just showing the first slide only, the AI governance, operation, and AI models.
Oh, okay. Hmm. Let me stop sharing and start sharing again. Can you see now?
Oh, yes, we can see. Yeah, we can see. The first slide we can see.
Can you see now the second slide?
Yes, yes, we can see.
Okay, I think yes. Can you see the enterprises must consider regulatory compliance slide?
You can see the agenda.
Okay, now,
No, also it's showing agenda only for us.
okay, now, okay. Um, 1 minute, maybe.
Yeah, it's now moving. Yeah, I think you have to scroll slide by slide. Then only it will
Yeah,
come.
that's fine. I'm not going to make it. Let me do this. Okay, it is bigger. Can you all see now? So you can see the enterprises must consider
Yes,
regulatory compliance, right? Okay, very good.
yes,
Okay. So going back to what I was saying, that all these applications are business applications, and those applications, when they're using that model for fraud prediction, that whether a transaction is fraud or not, it essentially where all these acts come into the picture, right? Now, apart from the enterprise acts, there are also various kind of AI certification standards are emerging. So one of the latest AI certification standard is from the Responsible AI Institute, and they essentially creating the standards so that any organization can first see whether their AI models really comply to the standards. And these standards from RAII, they actually have made various dimensions and subdimensions around what an AI model can do, should not do. And those are available in their AI certification standard documents or certification standard measures. Now, this goes as a more, a requirement related to the compliance and related to the legal act. But when you get into the detail of a model uh, life cycle, then the risk factors that you can see are like this, right? So when a model is developed, obviously there could be data issues, the quality of the data, whether the data is properly groomed, whether the data is properly cleaned. So that itself is an issue, or it can be a risk. Then designing of the model, what algorithm is used, whether that algorithm is right for that particular model, that can be an issue. Any kind of programming and technical errors, which is beyond anyone's control, those can be issues. Inherent uncertainty in a AI model, right? Because all these models are predominantly probabilistic models. So there is an inherent uncertainty. One should continuously monitor that whether the model is really at the, whether it is predicting properly, whether the scoring request, the prediction request it is getting, whether the features in those prediction requests are in line with the feature with which the model was trained or not. Then also another big thing is the inappropriate use, whether the right applications are using right model. Maybe an application which is not supposed to use a model, it is still using it. So, or it is just using it because there is no equivalent model is available. Or a model may be out of its shelf life. Every model, uh, when it is in production, typically there is a date provided that okay, you cannot use this model beyond this date for various reasons. But some application may still be using a model beyond its actual valid date. So these are all typical challenges, I'll say key challenges or risk factors associated with running a AI model in production or to be used by the production grade applications. And then comes that one should also keep the evidence of process governance and all other facts related to the model available so that the company can prove to the auditor that yes, all the model related compliance requirements are met. Now, to ensure that AI model in production meets or really don't run with these risks, people need to do a lot of different things, right? But for doing that, there are some challenges in implementation level, and some of the challenges what I put there in the right side, those are like what we typically hear from various customers, like documentation of all the model inputs, behavior validation. Doing it in a manual way is really a problem, or the current existing practice in that organization and the tools they use, they don't support operationalization of AI at scale. I mean, if an organization need to put AI models, I mean lots of AI models in production, they don't support it. Existence of various tools and technologies, any organization they typically use multiple technologies to build a model, depending on data scientist or what he likes, which kind of tool. So there is no standardization as such. So that itself is a problem. Then lack of consistent automation, uh, that itself can be a problem. Every lines of business in an organization, they may have their own requirements and constraints for model development or model production, model monitoring, how to take care of that. So these are essentially the various challenges and requirements. Requirements are primarily around the compliance requirement from the legal authorities or within the organization itself. Now, with this, let us move to the solution. So how this kind of challenges related to using an AI model in production can be addressed. So the heart of this solution, or the first thing any organization need to ensure for AI governance solution is basically creating a common operating model for the AI model. So here, when I say common operating model, it's more like common operating framework, which has a common process, platform, and policies. And that common operating framework needs to be used by all the models which are developed and productionized in the company. Um, so what should be the goals for that kind of common operating framework? So first is, it has to be having some kind of approach or mechanism to support configurable and automated governance flows with policy enforcement. So the policies are coming from all those legal authorities, which are typically from the government as well as maybe from particular industries. So the automated governance workflow is a must with the policy enforcement. Then the second goal is the continuous monitoring of the model. Majority of the time, we basically, the data scientists, we think that, okay, I've developed the model, it is in production, and there it ends the story. But it's actually not. It's just a beginning of the story. Because after you put the model in the production, then actually the real production gets scoring requests that starts coming to the model. And that point of time, the model can show various kind of behavior, like starting from bias in the model, drift in the scoring data, the quality of the model, the prediction itself may go down. Whatever the data or the prediction made by the model, that needs explanation, because you just cannot say that a model has predicted something. Say a model has predicted, no, this person cannot be given a loan for a particular house. Then there is a need to explain. The customer can come back and say that why you have not got that loan, right? Then robustness of the model against any adversarial attack, the confidence, how confident the model itself is about its prediction. So the continuous monitoring of the model behavior is very important. Along with that, whenever the model behavior is really shifting from what is expected, then immediately alerting to the respective stakeholders, like the model owner or the model developer, or the whoever the people responsible for the model. So immediately alerting them what is going on, right? Third thing what comes into the picture is the capturing the fact about the model, which essentially ensures the transparency. In the AI, in the world of AI, the transparency is of phenomenal importance. Unless our AI model is transparent, people who are using it, or whoever the stakeholder for the behavior of the model, like the loan prediction model, credit prediction model, so the end customers, they should not get penalized. So capturing the fact is very important. And when I say capturing the fact, means starting from what data is used, what algorithm is used, what kind of validation was done before the model is put into the production, what is the behavior of the model in the production. So all those things should be captured in a configurable way in a central place and should be available whenever somebody wants to know those facts about the model in a legitimate way. And then flexibility and optionality. This common operating framework should be able to uh, should have enough flexibility and optionality so that the models developed and deployed in multitude of platforms can be still governed by the single umbrella. So let me move to the next one. By the way, till now, is there any question? Any thoughts? So actually, I'm not able to see any question. Shogo, will it be possible for you
Yeah,
to?
yeah, sure.
Mhm.
So, Mr. Debashish Dasgupta, he has asked a question like, how can we assume the validity date, that is the expiry date of a model, when we are newly designing a particular model?
Okay. So Debash is the answer to this. You don't need to. So that is the reason uh, model development life cycle has various kind of persona involved into it. Like if you see this second diagram in this slide, there are various persona involved in it, like model owner, model approver, data engineer, model developer, model validator. Now, if you are working as a model developer, you really don't need to care about model validation date. That would be the responsibility of the model owner. So when the model owner is going to uh, take a decision that how long the model uh, should be available for use in a valid way in the production, he will basically tell that information to the model deployer, and model deployer will ensure that after that date, anyone is trying to use the model, they will get some kind of error. Does
Uh,
that answer your question?
yeah, he said yes. Yeah.
Okay.
So I have one question to ask.
Mhm.
From yeah, so like we know, like one of the area within the trustworthy governed AI is explainable AI, explainable machine learning. So we are listening to a lot of, we are reading also a lot of papers about the explainable machine learning, how to convert a black box model into a white box model, especially in case of deep learning. So deep learning are considered to be black box models. So there are a lot of research in the European circle as well as in the US that is going on. So can you please shed some light, like what should be the appropriate approach of converting a black box model into a white box model, of especially with reference to deep learning?
Yeah, but I think that would be a little bit digressing from the current topic.
Yeah.
If we have time after this session, I mean, at the end of it, I would be happy to, get into that discussion. But there are multiple ways. You can create a proxy model. You can create a surrogate. You can use Shapley type of mechanism. There are multiple ways to do that. Uh, so I can address that question if I have some time after this main
Yeah,
flow.
sure, sure.
So on the AI governance workflows, so there are typically two type of approaches the companies are adopting. One approach is they create multiple workflows to take care of a model, and those multiple workflows can be starting from the basic model inventory management workflow, where it manages the model start to end, the model entire life cycle. Then model change management. Anytime somebody comes and says that no, model is not performing well, the model has to be changed. A new version has to be created. Model review workflow, that how a model can be validated by a completely separate group. So every organization typically will have a separate group like quality control group who can come and they can validate the model as a third party independent group. Then model performance monitoring workflow, that itself can be a separate workflow where a set of people just keeps on monitor the model performance, and if anything goes wrong, they can feedback the difference. Issue management. Now, this is one approach where multiple part of end-to-end model lifecycle is taken care of by different workflows. Another approach is where one can create a single workflow which covers entire thing, including the change management, issue management, everything. So both the type of things are possible and used by the different organizations. And the reason I'm trying to show this thing to all of you, so that you have the exposure that, okay, all these kind of things are possible when it comes about AI governance workflows. Next, let us get into the what are the typical metrics which are measured by the during the model monitoring. So first is the performance, the quality. So basically the accuracy, whether it is regression model or classification model, all kind of accuracy parameters. Then comes confidence. Okay, there is a prediction, but how confident the model is about that prediction, that is very, very important. Unless you have that number, you really don't know whether you can rely on that prediction or not. Fairness, whether model is biased towards certain things based on maybe the demographics of a person, or maybe a particular type of food or particular type of country. So the monitoring the fairness is a paramount important, because that is where AI ethics also come into the picture. Robustness, uh, whenever there is a adversarial attack, whether the model is able to protect itself. Okay. Explainability, we are just discussing about that. Okay, every prediction from the model, whether it is deep learning model or non-deep learning model, that should not matter, right? Whether the prediction from a model can be explained in some way or other to the in general human language. And then comes the drift, which is also very important, right? Like when you train a model, you use a set of training data, right? And so the model is as good as the training data. It only knows its universe is the training data. Now, when you have put the model in production, the data that is coming for the production, that data may not be exactly similar to the training data. So that means there is a drift. And unless you monitor the drift, you really don't know whether to rely on the model's performance or not, the prediction from the model or not. So these are the very, very important monitoring metrics for AI models. And then comes the model facts. So what exactly the model facts? It's something very similar to, say, when you go to the market and buy a food product, right? Typically at the back of the food product, you will see every information about that product, right? What all ingredients went into it, what kind of certification it has, when to use it, and how to eat it, the entire thing, right? So this model fact is something very similar to that. Before using an AI model for prediction for in production, the group would want to use that model for their application. They must know all this information about the model before they can take a decision whether to use this model or not. Or later on, say the model is predicting something which is not acceptable. Again, one can go back to the model fact and see what all went into developing that model, so that they can make some informed decision whether to continue with the model or not, or to make a new version of the model or not. Um, Again, before going further, let me ask, I mean, any question so far? Any other question?
So, dear participants, here, if you have any question to ask uh, till now, so you can please post your question in the chat box, and Mr. Mujumdar can answer to your queries, because this is one of the very important area in the domain of AI and the future of research and development, as well as the industry focus, as far as the big giants like IBM is highly focusing on this bigger domain. And I believe that in 1 or 2 years down the line, India will be focusing on this particular domain as well, because this is one of the key challenging area as far as the AI model creation, the development, as well as the building the trust among the end users is concerned. So I think this is one of the very important area, very challenging area for the AI developers, AI model builders, as well as the people who are working, specifically the companies who are trying to digitally modelize their infrastructure using AI. Not only banking sector, because Mr. Majumdar is focused on the financial sector, but as far as I know from the Indian context, a lot of AI applications are being done in the core infrastructure sector as well. So, so that requires a lot of trust among all the stakeholders who are involved in this domain. So, yeah. So I have one question for you again, just to ask you another question. Like, can you please just give us an idea? Like, is there any solution, like any technical solution or a platform which is available, especially on behalf of IBM? Like, IBM is kind of a pioneer in this particular field, which basically can be used for entirely uh, using this particular platform as this concept of governed AI. Is there any platform? So if you can, in the latter half
Yeah,
of your,
that's what I think. That's what is my next slide about.
absolutely.
Um, so wherever you are seeing as a cloud pack for data, it is essentially a platform from IBM. And actually, this is a it is a more okay. So if you see in the left part, these functions are nothing but the AI governance functions for a end-to-end life cycle of a model. So first thing is a control. So control means the AI model inventory, governance workflows, policies. And then comes the building of the AI model, like the getting the data, creating the code, running the code to create the model binary. And then also comes the metadata, right, which is of paramount importance when you have multiple models running in production. So you need to have a lot of extra information about the models. Then comes the deployment. Now you need to start a runtime of the model, right, which can then start serving the request, whichever coming to the model for prediction. And that runtime can be a runtime which is staying there forever for online predictions, or for the batch predictions, you can just start the runtime any point of time and do all the prediction, and then the runtime can be dismantled. And then comes the monitoring and explanation again, going back to that, every prediction needs to be explained. And also gathering the facts in every phases of the model life cycle. On the right side, if you see, what I was trying to depict is that in every organization, there would be some shared technical services, and then there would be the lines of business. And each lines of business, they will basically make use their own technology to develop and deploy the model. So here, the platform from the IBM, what it can help is in the CI governance, it essentially can help to set the basic control with the governance workflow, the policies, and all the various stuffs related to the governance. Then the model development can happen using any technology. But then the metadata for all the models, like who has built it, what kind of info data has gone into that, all that things can still be managed by the IBM platform. The model deployment can happen in various technology also. So the development as well as deployment of the models can happen in various technologies. But the monitoring ideally should again happen in the same technology, which is again the IBM Cloud Pack for data. Optionally, some in-house monitoring happens, but those monitored metrics can also be funneled through IBM platform, so that there is a central repository where all metrics related to the model monitoring across multiple models are available. And that is very important because that is where the one basic leg of the governance, right? Unless you monitor the model during in production, you really don't know whether you are relying on right kind of things or not. And then explanation again, cloud pack for data can be used, and also storing all the facts and also using it for that also cloud pack for data can be used. In the next few slides, I'll just try to give a glimpse of these things. Now, before that, again, another high-level architecture which shows how all these things will work together, right? So, model essentially has these four main phases in the life cycle, right? Development, validation, deployment, and scoring in production, and then monitoring. Now, all these various stages, they need data. So you need to get, say, training data, you need to get validation data, scoring input, ground truth. Also, at the end of this each stage, the other kind of data like model binary, model reference, or validation report, or scoring output, that also needs to, those are also data getting generated, right? So those also need to be managed. Now, all this data access essentially can happen from various data sources. So the data can be stored in, again, multitude of data sources, right? Maybe some relational database, maybe Oracle, SQL Server, or IBM DB2, or maybe Hadoop, um, or maybe NoSQL databases like MongoDB or Cassandra. So data can be in various places. So to manage that data, typically organizations use something called data fabric, and that data fabric itself will have various type of features like searchability for data features, models, access control, data protection, figuring out the lineage of the data and the model, ensuring the quality of the data. Now, the through the data fabric, the data can be actually go back and forth to various phases of the model life cycle. And this entire model lifecycle can be essentially put through a lifecycle automation, the CI/CD platform. And that entire automation can be then managed or governed through the lifecycle workflow with governance. And the data about the model, which are model facts, then can be stored in something called the fact sheet, right? So this is the way all the various aspects of governance will play together with the model lifecycle. Now let us see some of the examples of the tools. Again, these are from IBM tools, but uh, other companies can also have similar tools. So this is kind of a governance dashboard where the various models can be seen at a glance. Like one can see metric-based model breakdown, that how different models are doing in terms of their monitoring metric. One can see where the models are in terms of reviews and validations. One can see the tier-based breakdown of the models of various tiers. So in the model risk management or the governance itself, there would be different models in different tier, right? Some models would be highly sensitive, so they're tier 1 models, whereas some models may be tier 2 or tier 3. So this dashboard essentially creates that. Then the life cycle flow, what I showed that itself can be made available, so that anytime a new model is conceptualized, it will basically flow through this life cycle, starting from capturing the details of the model's candidacy validation, that why do you need this model? It's not that we'll just develop a model and anyone will use it in production, right? One should plan beforehand that for the so that there is enough justification for using a AI model in the production. Then how the data sourcing should happen, how the source data would be validated, then model development, development uh, of the model, the validation of that part, then the validation of the model itself, like this deployment, any kind of change request that may be needed. So everything essentially one can uh, put in a workflow, and that workflow can be created through a tool in IBM Cloud Pak for Data. Next comes governance metrics. Like as I said, that there could be various kind of metrics one may need to monitor: fairness or bias, data and model rate, accuracy, explainability, in kind of other in-house metrics. Like every model, depending on what that model is doing, there could be some different kind of metrics that may need to be monitored. Then from IBM research also, there are various different metrics available. But once the models are put into the production, basically for each model, you can see this kind of tile. And this tile essentially has all the various metrics into this, what one can keep on monitoring on a regular basis. I hope this diagram is legible. It was made to show it as a actual presentation, but since I'm not able to do it, but I hope it is legible. Shobha, is this legible, this diagram?
Sir, we are not able to view this. Only the left-hand side block we are able to see.
Only the left hand side? Okay.
Basically, we're getting the silhouette of these two
Can you
inverted
see
L
now?
shape.
Can you see now?
Actually, sir, little because of the
Go ahead.
we're not able to read the content in these two vertical L black shaped boxes.
Oh, okay. Anyway, I'll share this content so you guys can use it later on.
Okay, thank you so much, sir. This can be shared.
Okay. Okay.
Sir, may I ask a query? If
Sure.
Sir, recently we also had a presentation by the principal scientist of TCS, and he has explained about that how he has used certain radar signatures, uh, uh, in which he has explained the unobtrusively way of seeing the uh, the, the 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 activity of the personnel for any kind of modeling. Like they were wanting to know that how much the viewers are watching, what all they are watching via Netflix or the other OTT apps. In that also, he said that a lot of data has to be collected via many cameras or via some radars. And after that, he has used that supervised modeling and then training the model and then testing it. And then accordingly, then he could come up with one particular model. So and he also mentioned what you today mentioned, that there are various metrics in developing a model. In the beginning, which you have explained, the precision and the performance, confidence, fairness, and the drift part. So, is it what we can, what I can understand that in the next slide, once you explain about uh, the dynamic nature of the model, and we need to monitor it regularly. So, so can we assume that to have a model having the longevity, so we must always have, since it has got a dynamic nature, that we must always monitor it, and we must keep on adding the metrics which can arise from time to time.
Yep, you're right. So first thing is that one has to continuously monitor a model for the metrics which are already decided to be monitored for. So here are examples of some metrics, right? Like fairness, data drift, accuracy, explainability, some other in-house metric. Now, not necessarily all metrics would be applicable for every model. So before even a model is put into the production use, again, the model owner and maybe with the data scientist needs to decide which all metrics they want to monitor for this model. So then the model should be configured for monitoring of those metrics. Now, as the model is running in production, they will basically capture, it will automatically. So there is a tool which will automatically capture those values of these metrics every day, every hour, every minute. right? And if the metrics look good, then everything is fine. One and the model owner may continue to use that model, or the model owner allow other people to continue to use that model in production or whatever the time frame till the model's expiry date. But if the metric values from, say, hourly basis or day-to-day basis or whatever, if it goes down or goes up, beyond certain threshold, then typically an alert is sent to the model owner saying that, okay, model is not really doing good. Then model owner has to take a decision whether the current version of the model should be continued, or new version should be created, or the model should be immediately brought down in the production. Right? That also happens. Sometimes it may be needed that if the model metric, maybe precision is going beyond, say, 30%, just immediately shut down the model. Okay, maybe that kind of thing also can happen. So continuously monitoring the value of those metrics over a period of time, maybe every minute, every hour, every day basis, that is of absolute importance for AI governance. Because developing the model is just the first part of the story. It is just you create kind of a template to start using it. Unless you start using a model in production, you really don't know how good or how bad the model is.
Okay, sir.
Did I
Thank you,
answer
sir.
your question?
Yeah, yes, I got it, sir. Thank you, sir.
Okay.
So also just
So,
to, yeah, yeah,
Mhm.
yeah. So also we'd like to welcome Professor Shalaf from IIT Kanpur. He's the Dean of Academic Affairs from the IIT Kanpur. So Professor Shalaf said also that this moment Mr. Shourabh Majumdar, he is delivering his talk on the governed AI. And just to inform you that he is also an alumnus of IIT Kanpur.
I see.
So yeah, so he's
Hi,
there.
nice to meet you here.
Hello, Dr. Saurabh. I think Saurabh, we can continue, and please take your own time.
Yeah, I may need another 5 minutes. That's it.
Yeah, sure. Feel free.
Okay. Thank you. So I think the next part is we discussed about workflow. We discussed about monitoring. Next part is about the fact sheet, or how to gather the fact about each and every model. And again, that fact essentially starts from why even the model is conceived, uh, what is the purpose, to the level of what all used to train the model, where from the training data comes, what kind of features, and then when the model is running in production, the continuous information about the metric which are continuously monitored for the models. Then at the high level, the fact should also show that, okay, what are the different stages the model has gone through. There can be different versions of the models. Maybe one version was already running in the production. Now it is turned off. Now there is a second version is running. So the entire life cycle about the model. And then also, as I was discussing about the AI model certification standards, like the standard which RAII has come out with, Responsible AI Institute. So they have come out with different dimensions and sub-dimensions to be certified for, right? So based on these model facts, even those certification dimensions itself can be monitored, and one can always say that, okay, yes, my model so far, it is meeting all standards as required by RAII Institute, right? So these all are the necessary things about the gathering the model facts, and also using the model facts for various purposes. One can also, or one may also need to use model facts just to explain it to the final users. Like as I was giving that example, say I went to a bank and asked for a loan. and the model, they said that, okay, no, my model says that you cannot be given the note, then I can ask that questions to the to my bank that, okay, why you have to explain it to me, and I'm asking a legally valid question, right? So now to explain that, that also may need the model facts that why a model is saying that. Um, so this is kind of a reference architecture again, especially using the IBM tool, but this can be something equally applicable for other technologies also, not just for IBM technology. So our AI governance platform, it essentially needs some basic key characteristics, like it should be able to integrate with the existing technologies that a company is using, because every company have already invested in multitude of technologies to develop the models, right? Then it should have a flexibility, this AI governance platform, so that it can integrate with various requirements of lines of business. It should adhere to the various security standards, and also, given the current scenario where all the applications, they run in different kind of clouds, so the support for hybrid cloud environment itself is a big requirement. You will get into the details of this slide, but just to mention few things, like the model monitoring itself can happen in an integrated monitoring, where you can define a wrapped abstraction which internally calls a model endpoint. Or there can be active monitoring, where the application that is calling a model endpoint may need to call a authorization interface or different kind of interfaces. Or it can be even passive monitoring, where model is directly called by the application, as in this red arrow, and then there are some the data about models behavior, like this is coding request, this is the response, that can then be passed through the monitoring interface to uh, come out with the monitoring metrics. I'll just take maybe a few more minutes just to quickly explain the journey. So typically how all the organizations are doing it. Typically, they will have a point of view that how they want to build a AI governance platform, that they will run some proof of concept using different technologies, and they will select the technology. And then they will, using that technology, they'll essentially configure various kind of operational and risk management policies, various kind of strategies for integration with their existing technologies. And then they will roll it out for the first set of models, maybe from one LOBs, which typically they will set pilot. And once that particular thing is successful, they will go for other lines of business, the models from other lines of business. So this is a very standard way people generally will go for this kind of AI governance technology. That's what I wanted to talk about today. Um, I'd be more than happy to take a few more questions, maybe 2 more minutes before Professor Soloff can join. And thank you again for joining this session.
Yeah, thank you very much, Mr. Mojumdar, for delivering your talk on governed AI. So, as I was just speaking in between the talk, that in today's world, since all the organization, even the government of India, is also highly uh, investing into the AI spectrum. So trust in the domain of AI is of a pinnacle importance. So also we have Professor Shalab, sir, who is an expert in the domain of data science and AI from Kanpur IIT. So he also know like what is the importance the government, even the organizations of different scale, are putting their effort in this domain of AI and modernizing the infrastructure. So therefore, I think this is a kind of ice-breaking session with all the enthusiasts of AI, the students who are basically uh, interested to venture into the domain of AI as a future. So I once again thank you very much for your time, precious time on this eve of our 75th Independence Day, where India is embarking into a future with a vision of improving its digital infrastructure. And thank you very much for your time. And I hope that we'll be in touch in future as well. Even the students also, if they are interested to venture into this domain, they can actively get support from you in their learning pathway in this field of governed AI, trustworthy AI, even the explainable AI, which is another area of importance. So
Sure,
on
sure.
behalf, yeah, on behalf of my organization, I express my heartfelt thanks. And again, once again, I wish you and your family happy Independence Day. Uh, Thank you very much, Mr. Pradyumna
Thank
sir.
you. Thank you.
Yeah,
Thanks for
yeah,
joining this sessions. It was really,
yeah.
I mean, it was good. Thank you. I'll just leave the call now.
Yeah. Thank you, sir. So we have just completed with the first session on governed AI, and we have with us Shalabh sir, who is an who is a stalwart in the field of data science, statistics, and AI. And sir would going to give us a talk on the title is Artificial Intelligence and Statistics, Complement or Contrast. Sir, happy Independence Day to you and to the entire family of Kanpur IIT. Just to introduce yourself to our participants, uh, you have done your postdoc in statistics from Ludwig Maximilian University, Munich, Germany in 2007 under Professor Dr. H. Stautenberg under Humboldt Fellowship, and also another postdoc in statistics from the University of Pittsburgh, United States in 2002 under Professor Leon J. Glaser. You have done your PhD in mathematical statistics from the University of Lucknow, and presently you are holding the post of Dean of Academic Affairs at Kanpur IIT in addition to your responsibility as a professor of statistics and mathematics at the Department of Kanpur IIT. We all know about your NPTEL lecture series on R. So those are some of the very enthusiastic and highly informative series you have published over there. So we are highly energized to listen to you, and it's over to you, sir, for your talk.
Thank you, Savya, and welcome all the participants and wish you all a very happy Independence Day. And yeah, first let me say that my background is statistics, and I was originally trained into statistics. So I am a converted data scientist. And right, so the only story behind my career is that when I was doing my MSc at that time, the computers started coming to India. So in fact, I had seen the computer for the first time when I was doing my MSc. So it looks like a very ancient time, like Harappa or Mohenjo-daro to you all, but that is the truth. So in fact, I'm the one who is growing at that time, and still I feel that still I am a student and I have not cleared my masters in statistics, then masters in data science, and now masters in artificial intelligence. But the fact is this: I don't know anything about data science or say artificial intelligence. This is because in this profession in which I am, it means I have to deliver to my students, I have to deliver to my community. So we really think from the basic fundamentals, right? When we started thinking about data science, nobody knew what is a big data science, and that is the reason that different people try to give different types of definition and introduction to the data science. And similarly for the artificial intelligence also, I didn't knew what is artificial intelligence. That used to be the baby. Somebody says that used to be the baby of the computer scientists. Somebody told me that this is the baby of the mathematician. Somebody said something like this. So I thought that, okay, why not adopt this baby and try to train it in my own way out. So in today's talk, this is going to be a very simple talk, a storytelling type of talk, where I would simply try to explain you that what is the interrelationship between the statistics and artificial intelligence. The reason is that when I try to talk about this artificial intelligence or statistics, okay, I can say share one thing, that now I am sharing my slides, so I cannot view any one of you. So if you have any questions, you can just stop me at any time. I cannot see any one of you. I can see only my slides actually. Right. So yeah, even if you stop me 100 times, well, that will not make any difference for me. So the reason why I took this talk on the day of independence, that okay, that I just want to discuss with you. I may be wrong, that whether artificial intelligence and statistics, are they really independent? Are they really complementing each other, or they are in contrast to each other? Because nowadays, when people try to talk about AI, people try to talk about only some algorithm. They want, okay, there should be a software, there should be an algorithm, they should have a data, and they should only just run the algorithm and they should get the outcome. Well, that I agree. Being said, that is what we are going to do. But then there is always a difference between a compounder and a doctor. A compounder will always get the medicines or the prescription from the doctor, and the compounder will prepare the medicine exactly in the same way as the doctor has told her or him. But the compounder does not have this liberty to develop her or his own medicine. So now the first decision what you have to take in the beginning of the talk, whether you want to become a compounder or a doctor. So in my opinion, well, you all are progressive children, or say progressive students who are good in studies. So I expect that you all become the doctor and try to develop something new, rather than trying to copy and paste the algorithm which other peoples are developing. Well, one should use them, but on the other hand, the expectation from a good student is that that a good student will be contributing towards the society also. So from this point of view, I thought today that let me try to introduce this artificial intelligence from a very basic perspective. Because in my opinion, it means every science we are using in our day-to-day life, but we never thought in that direction, that what are we going to do. So I will take a very elementary introduction, and then I will try to show you that whenever you are trying to use any tool of artificial intelligence, what is the story behind it? Is it statistics or something else? Right. So let me now begin this talk. So you see, why human being is considered to be the finest creation of nature or God? Why? Means there are animals, there are instruments, means everything is created by God. That is my personal belief. But then what is there really unique in human being, which is trying to establish her or him as a superior to many other creations of the God? This is, in my opinion, is the availability of a wonderful component in the body that is called a brain. Why this brain is important? That the brain gives us the power to think and analyze the data. And the fuel for thinking is the natural intelligence what God has given us. So every human being has a natural intelligence. And you can, if you try to ever think the way you try to take your decision, the speed at which you try to change or revert your decision very quickly, the way you try to consider many important information when you are trying to take a call. Suppose if I simply ask you that how much time you are going to take from your home to college, In a fraction of second, many factors will come into your mind. What's the time? Is it a office time, time for time of crowd? How much is the distance? How much is the uh, means say the cost of using different types of vehicles? What is the time that you are going to take depending on the vehicles, etc., etc. You cannot even list all those components, but in a fraction of second, all these factors will come to your mind, and then you will take a call. And even if you start by say, suppose by your scooter, and suddenly you see there is some crowd in your way, means immediately you try to take a different path so that you can reach your destination in time. What is this? This is natural intelligence. And that is the precise reason that why human beings are so important. Now, if you try to see, well, I means I am the one who has seen the growth and development of the computers. So personally, I feel that one of the finest invention of human being are the computers. Right. If you ask me, when I was doing my MSc in 1992, at that time we used to have the computers which they could not had any means hard disk. Means the biggest size of the data storage was 512 kilobyte floppy drive. Then I was very happy when I got a 1.44 MB floppy drive that was half of the size. And then I was very happy, and I couldn't believe that when I saw that, okay, there is going to be a hard disk whose size in say 1 GB or 1 point something GB. I couldn't imagine that how many numbers are there in the GB. The gigabyte was the only unit at that time which I had studied in my physics book, that okay, these are the different units of measurement. But now the things are changing. So, and then you can see there's a tremendous growth in the computers, computer architecture, computation, performance, everything. Now, why these computers I am thinking as the finest invention of the human being? Because it can replicate many things which are happening in nature in much, much less time. Yes, humans are intelligent, but if I ask you to tell me the table of 29, possibly you can do it, but you will take a very long time. But instead of that, if I try to ask the computer through some programming, possibly it will take a much shorter time. So now, if you try to see what human being thought, okay, we have got a thought process, we have a power to think, and the computers have power to perform faster. So the computers were used to replicate the natural intelligence, and this possibly gave the idea of what is called as artificial intelligence. Nothing more than that, in my opinion, if you try to think from the root level. Right, after that, artificial intelligence can be defined in different subjects in different ways. But the question comes to what is the fundamental thing? So now if you try to see, whenever we are talking of the artificial intelligence is simply consisting of some algorithms, some programs, whether they are trying to implement an algorithm or anything else, right? That can be a program to just sum up the n natural numbers, which is one of the easiest and elementary program which is taught to us when we are trying to learn the programming. But if you try to see, I remember that when I was trying to learn the programming language, my teacher, at that time it was in a very naive stage. So my teacher was always telling me, okay, try to use a logic that how you can sum this a natural number, or how you can do this thing. Then initially I got badly confused, and I asked my teacher, and I was really frustrated. I said, sir, from where to bring this logic? And his answer, I don't know where he is, but his answer was, Shalab, you just practice it and you keep on programming, you will develop the logic. And then I saw it is correct. Once we practice, once we are into the programming, then many different ways comes to our mind by which we can execute the program in a faster way, in a much better way. And this depends on the IQ of the program. So essentially, if you try to retranslate everything, Whenever you are trying to write a good program for the artificial intelligence within codes, then it is the capability of the programmer that how good or how bad is the programmer. Now the question comes here, how you are trying to say the programmer is good or bad, or the program is good or bad. So what you try to do, whatever you are observing in a natural way, whatever your natural intelligence is telling you, you want to replicate the same thing to the program also, right? If you try to say see at Google Maps, as soon as you try to go into a route where there are multiple options, if I ask you from your natural intelligence which route are you going to opt, you will say, okay, the route which is faster, in which I take less time. And if you try to see, Google also does the same thing. It will give you an option, okay, please follow this route, and it will avoid say this road jam, traffic, etc., etc. So whatever you are thinking from your natural intelligence, that is being implemented in the Google through some program. There is no human being sitting inside your phone or inside your laptop who is guiding you. This is only the programming which is based on artificial intelligence and which is done by a natural human being. So that means in order to make the good programs, what do we need? We need to have a good logic with programming skills, because logic is the one who is going to govern the programming skills. So now the next question comes here, what is a logic, right? So the type of logics for a good outcome can be a mathematical approach or a non-mathematical approach. For example, if I say, okay, I will give a grade A. For example, in IT system, we are trying to divide all our students after examination into different grades, like A, B, C, D, and fail, etc. Well, in different system, sometimes they are based on the percentage also. Yes.
Sorry to bother you, sir. May I know, sir, have you started changing the slides?
Yes, I have changed.
No,
okay,
sir, actually, sir, we are in the no, sir. We are only seeing the first introduction, the first slide only, sir.
Oh my God!
Now,
actually, I am in the fifth slide. Okay, let me try to show you. Can you see this slide now?
Now we can see, sir.
So I will do one thing. I will not actually. And now
they are changing. Now they are changing, sir. Yeah.
So I will do one thing, that I think there is some problem. Actually, this Google Talk always creates some problem. So I will just simply use the natural mode. I will not make it full screen actually. Right. So you can see that this was my actually first slide, and in which I was talking about the brains. And then this was my next slide, in which I was talking about the invention of the computers and replication of the natural intelligence in terms of artificial intelligence. And this was the slide where I was talking about that how are you going to create good programs for this AI, right? So, and now I am in this slide actually. So if you try to see, as I said, the success of a good program is dependent upon how much good logic one has. So now when we are talking about the logic, there can be a logic which is mathematical and which is non-mathematical. For example, if I see at IT Kanpur, as a professor, my role is to divide all my students into different grades, like as A, B, C, D, F, whereas some universities are giving the marks also. But anyway, so now usually we declare that, okay, what will be the cutoff of the marks in terms of grade A, B, C, D. Suppose I said, okay, I will give grade A to all those students who are wearing a blue shirt. Is it going to be acceptable? Certainly not. Means I ask this question and everybody say revolts. No, this cannot happen. But on the other hand, I say, okay, I will take some quizzes, I will take some exams, I will give you a project, I will give you a viva, and based on they will have different weightage and then weights, and then based on that, I will try to calculate your total marks. And then anybody who is getting more than 80% marks in the exam, that is where that candidate, that student is going to get a grade A. This second option become acceptable. So the question comes here, why the first option of blue shirt was not acceptable and the option of second uh, yeah, and the second option of this 80% marks is acceptable. The reason is very simple. The second option involves mathematics. Right, mathematics now you know as an exact science. Okay, can you see the slide now? Is it changed?
Yes, sir, it is changed.
Okay. So now if you try to see that whenever we are talking of the mathematics, mathematics is always an exact science. But in real life, whenever you are trying to do something, there is always some amount of randomness into it. Even if I ask you that you are going to your college for the last 1 year, but if I ask you that how much time are you going to take, who can tell me, okay, it will take 20 minutes, but it is not really going to be 20 minutes always. That can be 19 minutes, that can be 22 minutes, or that can be 24 minutes also. So there is going to be some random variation because of different factors in your decision. So mathematics alone is not really going to help us in developing a good program which is close to the real life experiment. So we have to involve some element of randomness, and as soon as we involve the amount of, or some element of randomness in the mathematics, then we have statistics. Right. So now statistical tools are based on mathematics. No doubt about it. We are doing mathematical statistics, and now we have a computational statistics. But again, this is based on mathematics. So all these statistical tools are based on mathematics, and their single aim is to provide an outcome as expected by the natural intelligence. So if you try to see, we have natural intelligence, we have a computer, we have a program, now we have a logic, and now we have a subject which is trying to associate the subject with the logic. So now this rules of statistics can give means different types of mathematical formulation to a problem, and the best part is this: they will also involve some level of uncertainty into it, so that the outcomes are more closer to the real outcome, and they have better acceptability among the users. For example, if I ask you, suppose all of you are suppose sitting in my room, and if I ask you that what is the average age of the people in this room, very naturally, without doing anything, without thinking, what you will do, you will simply try to take some values, and you will try to find out the arithmetic mean, and you will tell me that this is the average value. Then my question is, why you have not found the geometric mean? Why you have not found the harmonic mean? Why you have not found the median mode? These are the simple measures which were taught to you all when you were possibly in class 8, 9, 10, 11. That these are the different measures of central tendency. But if you try to see, your brain indicated that, okay, you have to use the arithmetic mean. And now I can tell you that this is what we teach in our undergraduate and postgraduate program, then that in many cases, the best estimator to estimate the population mean comes out to be this arithmetic mean. So if you try to see whatever we are trying to teach after the 5 years of training, your brain is telling you without any training. The God has gifted us the natural intelligence, and natural intelligence is using statistics to give you the best value. Right. So now you can see here the use of statistics. I can give you a very simple example, which is a common example, that what is the role of artificial intelligence and how it can be implemented and what will be the different advantages. Suppose I'm just taking this simple example where nowadays many people are doing the online shopping, and Amazon is one of the popular places. Remember one thing, I'm not trying to advertise Amazon, but it is only an example to explain you. It can be Amazon or it can be any other website. Right. So what do? When you go to the site, you try to type some keywords, and then you try to find something. Right. Suppose somebody goes there, and you can see here there are different pictures. One is shirt, then there is kurta, then there is speaker, there is cutlery, there is a laptop. Right. So suppose there is a customer who goes to the website, and he or she tries to find out different things. Right. Now, what do? If you try to see nowadays, as soon as you try to browse something, after that, the next time when you try to visit it, it will give you some suggestion, it will give you past history. And even if you're trying to close the website, it may give you a pop-up. Okay, if you do this shopping, use this coupon and you will get a 10% code. That code was not coming in the beginning. And then even if you don't buy at that time, the next day you will get some email in which they will be offering you, okay, 10% coupon, 20% coupon, etc., etc. Why this is happening? What is this happening, and who is doing it? So if you try to see, when you try to enter into a shop, the shopkeeper doesn't know you. The shopkeeper will try to read your actions. They will try to ask you, what do you want? Shirt, kurta, sari, etc., or say cutlery or speaker, anything. Then as soon as you say, okay, okay, I don't know, then you will try to look at different places, and the place where you are trying to spend more time, you are trying to pick up more things, the shopkeeper will understand, okay, this is the place which is making you interested. You came here for only window shopping, but now these things are making you more interested in buying. Then that person will come to you and they will try to show you many things, and it is a good possibility that you may get convinced, you may get attracted, and you can buy them. So now the same thing can happen in the online business, because in online business there is no shopkeeper, there is no customer care people who can come to you to help. You have to help yourself. So now they are trying to replicate that shop on your browser. Right. So now, as in, suppose I have this Amazon site, and I want to know that, okay, how to attract the customers. Now, the customers are going to be attracted only when I'm trying to offer them the correct item. So what I try to do, I try to browse what they are browsing, and that is the reason. If you try to see, usually in the site, they will ask you to create a login, your email ID, phone number, etc., etc. They may not ask your name, but your phone number and email, that is always verified. Right. Okay. One reason is that if you're trying to buy, then they want to make sure that it reaches to the correct address. But then on the other hand, they also want to make sure that, okay, if they are sending you an offer, that is also reaching to the right person at the right time. Anyway, so let us talk now, come back to our jobs. There is a customer who is visiting shirt, visiting kurta, visiting speaker, cutlery, laptop, etc. And that person doesn't buy anything, but he leaves the website without doing any shopping. Now, the means that the owner of that website wants to know what to do, how to attract this customer. So they can always send some coupons, discounts, etc., etc. But the question is that, which coupon should I send to my customer? Shirt, trouser, kurta, speaker, cutlery, or laptop? How to decide? Think about it. Means, how are you going to do it? So if you try to see here, for example, and then you can see here that next time when you try to go through with the same site, it will give you here something like inspired by your wish list, inspired by your shopping trends. They are trying to attract, they are trying to do the same thing what the shopkeeper was trying to do when you entered into the shop. They just observe what are you looking more, and then the shopkeeper comes to you and they ask, okay, what do you want? Are you interested in this? But the question is how you will be doing it when the customer is not before you, and everything has to be done only by the programming, nothing more than that. You cannot go to the customer to their homes and ask them what are you going to do. So now the natural, you have to use your first intelligence to decide that how are you going to take a call. So as a human being, the natural intelligence suggests us that, okay, that how are we going to decide that what are the items in which my customer is more interested, or what are the higher where the chances are higher that my customer is going to means buy this thing. As soon as I chance means probability, Right. So you want to know what is the probability that this customer is more interested in a speaker or a clothing or a laptop. So one option, one logic which can work here is that, okay, any customer who is visiting a particular class of items more number of times, then that is going to indicate that the customer is more interested in this. And if you try to see number of times divided by the number of times the customer is visiting a particular group of items like a shirt divided by the total number of items which the customer has visited, including cutlery, laptop, etc., that is nothing but your probability, right? The simple measure of probability. Now, the natural intelligence suggests that, okay, we simply try to count the number of times a person is visiting a particular class of item. Then we try to create the proportion, that is your probability. And then I will try to see that, okay, wherever the hits are more, so then that corresponding probability is more. And so this person looks to be more interested in buying that particular item. For example, if I go to Amazon site and if I make, say, this 100 hits on the clothing, on, say, shirt, and say 5 hits on the laptop. So there is altogether I am hitting 105 times, and then the probability that I want to buy a clothing is 100 upon 105, and the probability that I want to buy a laptop is 5 upon 105. So obviously it gives us an idea that, okay, this customer seems to be more interested in buying a clothing. So now I have to give him the coupon discount, etc. on clothing. I have to give him offer so that he can buy the clothing. But now my question is this: how to get it done through this AI? AI means simply programming. What should be the logic? And you don't have time. You want a good solution also. So in this case, statistics enters into the scenario, and it rescues the owner as well as it provides solution to the customer also. So how it is going to do, if I try to collate all that steps, that is very simple. That in the first step, try to create a list of browse items, items which are browsed by the customer. Now try to group them in different, say, these groups. Is it clothing? Is it electronics? It is food item, etc., etc. Now within a group, you can say for example, clothes. The person can look for shirts. They can look for trousers. They found kurta, sari, etc. So now, if you try to see, then you are trying to. What are you going to do? Then you simply try to count the number of times the person is trying to hit on that particular group, and then you try to count it, and then higher the count. That means higher the probability, and then you will see that, okay, now I have to take a call that I have to send the coupon discount, etc., on these items. So now if you try to see in the steps number 2, 3, 4, and 5, whatever I am going to do, this is my, these are the suggestions from my natural intelligence which God has given me. But now the question is, how are you going to do it statistically? Or how are you going to do it in a programming way? Because AI is simply some logic which has to be programmed. But the question is this: how are you going to take a decision on steps number 3, 4, etc., or say 2, 3, and 4? Somebody is going to see the laptop, cutlery, clothing, etc., etc. So now here the statistics comes into picture. Statistics enters, and it gives us different types of solution which are going to give us an idea that what really we have to do in order to execute the steps 2, 3, and 4. Because at this moment you don't know what to do, right? And then whatever the outcomes are going to be there, they are based on sophisticated mathematics, proper logic, proper reasoning. And they have some, I mean, even if there are certain approximation, they are scientifically flavored and they are going to be acceptable, right? So for example, if I try to see here that how are you going to do it statistically, what statistical tools are you going to use? The first thing I will say, okay, as soon as the customer comes, it is he or she is trying to browse with different items. I will simply try to count them. Counting means the frequency distribution. And after that, I will try to compute their probabilities, their arithmetic mean, their variability, etc., etc. I will try to find out their different types of graphics, maybe histogram, maybe bar chart, etc., etc. So these tools are nothing but what we teach to our students under the descriptive statistics and graphical tools. Then after that, if you try to see here, the second step is, so now you have done the step number 1 and step number 2 together. You have grouped the items together. Now in the third step, you are trying to means okay, within a group, so suppose you have created electronics, clothing, etc. You want to group them together because the person is trying to view sometime clothes, sometime electronics, sometime food items, sometime cutlery, etc., etc. So the question is how are you going to do it together? How are you going to group them together? So this is the idea behind the cluster analysis. The cluster analysis tries to cluster the observations which are homogeneous in groups. For example, if I take a simple example, that suppose in your class means you have or in your college there are different people of different ages, and if I try to ask you to create a group, by your natural intelligence you will try to divide them into young children, smaller children, and then elder people who are in the faculty, staff, etc. So, and then you will see, okay, all those teachers, they will be under one cluster. All those students, I would say in class 9, 10, 11, they will be under one cluster. All those students who are in class 1, 2, 3, they will be in one cluster. So the question is this, how to get it now done? Right. Then there is here third step, that isn't a group. The person is going to search for shirt, trouser, etc., etc. Now, based on that, you have to, and then you have to decide what interests this customer more. Are they trousers or shirt? So now, what you try to do for me, statistically, trouser, shirt, etc., etc., they are my different variables, and I want to know that which are the variables which are more important for this customer. So now if you have a list of variables where you want to identify the important variables, then principal component analysis comes into picture. Right. And after that, suppose the person enters into your Amazon site once again. Right. Then you would like to see that, okay, what that person is going to do. And then based on that, before that, you want to send the customer the targeted advertisements, coupon, etc., so that the person can do the shopping. So for example, so as soon as the person enters into my website, I will try to say, okay, let me try to use here the discriminant analysis. Okay, this is the time, and yeah, I mean, say what really this customer is going to buy.
Sir, your voice is not coming. So you have kept on mute.
Oh, now I don't know how it happened because
Okay,
it
okay.
was
Yeah, it's now okay, sir.
now okay.
Now,
Okay, sorry.
yeah, yeah, it's absolutely, sir.
Right. So if you try to, can you hear me now? Can you hear me now?
Yes, sir. Yes.
Yes, sir. Yes, sir.
Yeah. Okay. So if you try to see in all this, in this very simple process that you try to do with your natural intelligence, I have given you here the tools, which are the possible tools which are going to complete this programming through AI. You have to use the programming for doing the cluster analysis, or say finding out this frequency distribution, descriptive statistics, graphical tools, cluster analysis, principal component analysis, discriminant analysis, etc. They have to come together in a logical way, and then they will try to give you the correct outcome. For example, if you try to see, this is your it's a very rough indication of this cluster analysis. If you have this data, suppose in this blue color, green color, red color, so this, they are all together, and this cluster analysis will try to create these groups of green color dots, blue color dots, red color dot together. And then if you try to see on the left hand side, there is a graphic which is like cluster dendrogram. It will try to try to tell you that how many clusters do you really want in your in this analysis to give you the better outcome. Similarly, we have here this principal component analysis, which is used to to identify the similar item, or it helps you in finding out the important variable which are affecting the process. Anyway, so we try to use them. And then we have here discriminant analysis, that it will try to give us a classification rule, that how are you going to classify a new observation. That is what we are doing every day in the class. We try to make our rules. Okay, anybody who is getting more than 80%, that student will be classified as grade A. Anybody getting between 70 and 80, grade B. Between 50 and 60 is a grade C, and so on. So as soon as the marks of the students comes, we will simply classify them into those groups. So this is our discriminant analysis, that okay, we have a rule that anybody who is going to get more than 80%, that candidate is going to get a grade A. So similarly, this discriminant analysis is based on some mathematical tool. Cluster analysis is based on some mathematical tool. And yeah, that is what we teach in the in our statistics program. All right. So now, and then these are well-defined mathematical techniques. For example, if you have a covariance matrix, you have to find out the eigenvalues, and then you have to see whichever is the highest eigenvalue, that is going to give you the idea that which of the variable is contributing the more, etc., etc. Right. So these techniques are based on certain logic. They are based on certain mathematics, and then they try to give you some outcome, right? So, and then you also have these different types of statistical techniques, which are Bayesian or frequentist. Bayesian means, okay, you are trying to use some prior information. For example, if you want to go to railway station from your home, then you always try to see, okay, if I go by this route, there will be heavy traffic, but if I go by this route, the traffic is going to be less. And then you try to take a call that you want to use your prior experience, and you try to take a route which is trying to give you the minimum time. Where in the non-Bayesian framework, we will simply start and we will try to take a call based on the set of data. So this is also happening. These Bayesian techniques are becoming very popular. Bayesian has only one problem, which used to be there because of this algebra. Algebra used to become very complicated, but now with these computation techniques, these Bayesian methods have become very popular. Many people are using this Bayesian information to get an idea what is really going to happen in future, right? Then means earlier I can share with you that we had only statistics in theory. Whenever we used to ask our teacher, okay, how are you going to do it? Then we say, okay, when you will get the data, then you try to do this type of computation. But we never had this type of scope. We used to do our calculations on a simple calculator, or at the most, by that time in India, we had scientific calculators, right? But now you have this high fast computing, high performance computer, which can give you a solution of any order of multiple integral in the minimum possible time. It may not be 100% accurate, but it may be more than 95% accurate. So with this the advent of computers, this I may not be able to do the algebra, but I can always compute it, and I can always give you the numerical value. And as a user, you are always interested only in the numerical value. You don't want to understand those theory, etc. Right. So then you can use this computational statistics, or you can use theoretical statistics, They are going to complement each other, because in competition you are going to use whatever you have developed in the theory. So this statistics will come here, and then they will try to help you in giving the program, and then you can implement the logic, and then you can develop an artificial intelligence too. Right. So if you try to see here that whenever you are trying to give a final product delivery, it needs to have computer programming, it needs to have statistics, it needs to have then, I mean, so-called artificial intelligence. Besides those things, you should know how to store the data, what is the data structure, how are you going to store it, how you can get the data from different sources, like some digital sources, this PDF, OCR, etc., etc. Then all these things together, they are only going to give you the successful final product. One thing is not really going to help you. And now it means after that, many people ask me that what are the statistical technique we can learn. So you can learn multivariate analysis, Bayesian analysis, applied statistics. There are many topics, computational statistics, programming with R, Python, any other, or any other language, whatever you want. But the thing is this: if you want to do something in artificial intelligence, you need to have these types of knowledge with you. Without that, you cannot make a fundamental contribution. I always say to my students that whenever they bring me something based on AI, I said, no, you have not developed it. Somebody has developed an algorithm. You have just copied, or you have just borrowed that algorithm, and then you have put it in your data. Somebody has used the data of on, say, medical. Somebody has used the data on healthcare. Somebody has used the data on something, food and groceries. That's all. It is not an invention. You are not going to do something new. You are simply trying to become a compounder. So try to become a doctor. So for that, you need to have a proper training. You should know how to write a program which can give us a good outcome. And I can share with you the type of problems that we get. Means okay, means I'm not an expert in artificial intelligence, but then means I have a team where different people try to contribute in this thing. So with them, I have learned a little bit, but I can see that whenever the problem comes to us, whenever we get some consultancy project, there is absolutely nothing that we know. We have absolutely no idea which of the tool is going to be there. But this is only the training in statistics, mathematics, computer, etc., and common sense, logical grooming, and natural intelligence. They help us. Okay, this is how you have to think, and this is how you have to write the program. And God willing, means up to now, things comes in a good way, and we get a good outcome. So thank you very much for listening with patience. And then, yeah, I'm open to your different type of question. I may not be able to answer all the questions, but I will try my best to answer the question whatever I know.
Yeah. So, dear participants, it's an exceptional opportunity for you to know from one of the finest person in the field of data science and statistics. And it's indeed, he has given us a good complementary and contrast and how statistics is complementing the artificial intelligence. So I would request all of you, means, if you have any doubt, to know from him anything you want to know about the model building. So sir, yeah. So we already have one question, sir. So I just
Which
uh,
language? By using data science, Python. Yeah. You see, that's a very confusing statement. And but I will say simply, means today if you try to see, means I am wearing a pajama kurta. The reason was that just before your talk, we had this function for the Independence Day. So then, okay, I had a pant shirt also, but then I had a pant shirt and a pajama kurta both, and this green color jacket. So I thought that, okay, this will complement the Independence Day feeling. Right, I can also wear a suit, coat, tie, and pant also. So the thing is this, I have both. And then depending on the occasion, I will use both of them, so that the mood of the uh, this function gets complemented by my dressing sense. Right. So similarly, R and Python are also the same thing. Both have very good language, both are free languages, but then they have their own advantages. For example, R is more statistically sound. That if you try to do any means up to now, whatever computation I want to do, people have created the packages. So I don't have to do the programming even I know this time series moving average ARIMA model, and I can do the programming. But if when I already have a built-in program, then why should I do it myself? So those things are there. So if your things are more statistical, then possibly R is going to be a better option. And this Python is also doing a great job. It has many good packages which can do the thing. But usually, if you have a very large data set, then I have seen from my experience that Python works. I'm not saying that R doesn't work. R will also work. So this R and Python, whatever you want, whatever you know better, you can use any one of them. And then it all depends that what you want to do, is it available in R or Python? Because everything is not available in R and Python. But now over a period of, I think the last 5 years, I have seen a tremendous growth. And now I am left behind. I cannot run that fast to grab up the things. So both are good. You try to, it is only a matter of a week to learn R or Python. So instead of getting confused, better is to learn both the programming language and then try to use whatever you want.
So,
And both are good.
also, sir, actually nowadays, lot of enterprise grade solutions are also coming up, like which the organizations are basically using, like H2O AI. I know one of the
Yes, yes,
solution which are very much, subject agnostic. So they
yes,
are pre-built models are there. So
yes.
fast processing is there. So,
Yes, as a matter of fact, I can share with you that means we have done different types of projects for government of India, etc., etc. We have developed something new, and then in this we have used a lot of Python actually.
yes, sir.
So, but if you ask me, I am more famous as a R person
Yes, absolutely.
because of my this NPTEL and MOOC
Yes,
courses actually.
yeah.
It
So,
is
sir, there is another question, sir.
yeah.
He is Kundru Shivakumar. He is saying
My
that
name is Puneet Vegan
yes,
I'm in IT Kanpur. Okay, so I'm interested in AI-based thesis in second semester. Whatever professor told us, please be focused on core. Yes, otherwise it will work. Load. How can I? Yes, I agree. Means you see, this is a okay. Means I will answer your question in a different way. In my first class, to all my students, I declare that in this semester I am completely with you. Next semester I will have a different students set of students, and I will be more dedicated towards them rather than you. My priorities will be towards those students. In this semester you are my first priority. You can call me 24/7. So no, so this is what, and as I said, that unless and until you know the fundamentals, you cannot develop anything new. And since you are from IT Kanpur, this society expects from you that you are going to do something new. So that is why your professors are trying to say that you try to concentrate on the basic fundamental. But my question is this: at IT Kanpur, your classes in a week for a particular subject are not more than 4 hours in a week. That means 1 hour in a day, or say this 3 to 4 hours in a day you are going for the classes. Remaining 20 hours are with you. You can also learn it yourself. Why do you want to depend only on your professors? If you ask me, means I have to learn all these things myself. I learned R, Python, etc. myself. There was nobody to teach me. I know that how this R came into existence. Means I have seen this development with my own eyes. So why you want to depend on your teacher? The teacher is trying to say because I have a course content and I want to make sure that the students learn this basic fundamental because that is going to help them in the future.
right.
Right. So you learn both.
Yeah.
Yes, okay. That's from Rishi Das. Okay, we want to learn from the past mistakes. Okay, but then there is always a memory-less technique. You see, I'm sure that Rishi, you must be more than 20 years old, right? Do you remember what type of mistakes you made when you were 1 year, 2 year, 3 years old? And would you like to learn from them now at the age of 20? Certainly not. But if you have made a mistake at the age of 19 that you were not going to the class because of which you have got the wrong bad marks, would you like to learn from this, or would you like to learn from your mistakes which you have made in the childhood? So that is why this memoryless properties are there, and as so as the as the time passes, their importance becomes low. For example, in 95, 96, getting a floppy drive of 1.44 MB was a dream, but now who cares for 1.44 MB nowadays? So now that is not important. I am more interested whether my hard drive of 5 TB is lost or not. 1.44 MB floppy I can give everybody free. So that is why this memory, which is up to a certain time, is important, but after that it has no value. So that is why we don't keep it with us. For example, I have a tape recorder at my home. Means I know in my younger age I used to listen music on it, but now I don't use it. But then, so it has no value because of my sentiments only. I am keeping it in my home. So in profession there are no sentiments. Any difference between clustering and classification? Yes, clustering and classification, these are two different they are just opposite. Clustering is trying to collect data of similar type together. You have boys, you have girls, so they will be coming together. You have ages, you have people ages from 1 year to 50 years. You will try to club them into 1 to 5 years, 5 to 12 years, 12 to 18 years, and so on. So this will be your clustering technique. Classification is that a student comes before you. Okay, sir, I have got 75% marks. What is going to be my grade? So now you try to classify it into whether that person will be classified into the students of grade A, grade B, or grade C. So this is called classification. Someone is asking, can we get the PPT of both the session? What is there in my PPT? And believe me, tell me one thing: how many of you have ever watched the PPT of others? Even I don't use this PPTs twice. Well, the concepts can be same, okay, but every time I try to organize my PPT according to the audience. In this talk, I had absolutely no idea about the audience, so that is why I had made it means extremely simple story type.
And sir, like last year also, when you have given your talk for this particular Independence Day session, you also used a very simplistic way of explaining the. I believe I remember that you have given your talk on the quantitative analytics. So that was the first thing you have explained, and this time also you have just given an extraordinary comparison between the AI and statistics and how it is complementing. So this is something I also believe, because I also take some training programs, so I understand like the students, even the professionals who are working in different domain but not associated with this field, they also have a kind of a question in their mind, like how they can go ahead with AI, and what kind of knowledge base they would be requiring before venturing into AI. So I think there is another question again,
Yes,
Rajesh.
yeah,
Yeah.
I can answer. You see, Rajesh, it is very simple. Data science does not mean only statistics. Data science, if you try to see, even if you try to see in your watch, the people can that can analyze what is the saturation level of oxygen. I don't know what is oxygen. It is only a chemistry person who can tell me that how the oxygen look like, or what is the structure, and to what this oxygen reacts to. So if you are a chemist, okay, try to understand your basic fundamentals. Try to see what type of data analysis do you want to apply your data. Right, number two. And then number three, yes, be assured you cannot expect from me that I know chemistry. Chemistry was a subject which after class 12, I was praying to God that I must leave. Similarly, you should not expect from yourself that you will be needing statistics. This is the same way if you get some health problem, do you try to take the medicine yourself, but you go to the doctor. So better is to, I'm sure that you will be in some institute, in some university, there you try to contact the people who are experts in the statistics, try to learn from them, yes. Then from their knowledge, you also try to develop yourself that how you can use it. And then, yeah, programming is such a thing which is now taught to every actually kid from the childhood. So you simply have to write a program. God has given you the natural intelligence and logic. So the only thing is that you have to compile all of them together. And above all, you need to have a determination and wish that I want to learn it. No options left in my life. The day you have these things, the roadmap is 100% clear. You will be on the expressway.
Yes, sir. It's a fabulous advice, I think. The participants who are actually here are mostly budding enthusiasts of data science and artificial intelligence. And presently, also we also have with us Professor Reza. He's the ABM Alim Al Islam. He's the professor of computer science and engineering from Buet Dhaka. So he has joined us. So actually, we are also working under him on project on. Determining the cybersecurity threats using the deep learning techniques. So Professor Reza is guiding us on that particular way. So we are actually complementing and trying to understand how the AI models can be implemented in different scenarios in
Yes.
different applications. It's indeed a really great talk with you. So it's an opportunity to meet you virtually to know from you. I think all the participants over here they have also got a fundamental knowledge. But prior to that, we had a session on governed AI, which is another area of futuristic introspection as far as the trustworthiness of AI model building and deployment is concerned. And now you have given us a fundamental idea of how they can start into their career of data science and AI, because there are a lot of confusion about this particular field, a lot of confusion, lot of things.
Yeah.
Thanks to too many, concepts and too many ideas are being generated. But knowing from you, who is basically one of the expert and the pioneer who has seen the transformation from the statistics to the today's day of artificial intelligence, is a fabulous opportunity for each and everybody to know. So so I think there is no more question, and it is indeed an opportunity. And my heartfelt thanks from on behalf of my small organization to have you with us every year. Like last year, also we are having a privilege of listening to you. I express my thankful gratitude to you, and once again, happy Independence Day to you, sir, to all your students and the every stakeholders of Kanpur IIT. Happy Independence Day, and we look forward towards you also. If some of the students are interested to do some kind of a little projects or get some ideas, so we'll be very happy to get along with you to know from you, because association with professors and scientists like you is it's like a gem for every student, every people who are enthusiastic to know from you, sir.
No, no,
So
sorry. All my students are farmers better than actually me. Right. So they know, say they are farmers far ahead and better than me. So yeah, so absolutely no issues. You see, this artificial data science, you only need to have a wish that
yes,
you want to learn. That's all. Nobody is small. No organization is small. And when anything is starts, this is always small.
absolutely, sir.
Right. So, Savya, hopefully, someday you will have a multinational company with you. This one, Miss, I wish you good luck and wish you all a very happy Independence Day. And it was really a pleasure to talk to you and listen to you.
Thank
Right.
you very much, sir.
Thank you. Thank you. So I will, you can leave and go to my other jobs.
Yes, sir. Thank you
Thank
very much for your
you.
precious time, sir.
Bye.
So, thank you very much. And now we already have Professor Reza with us. Sir, can you hear me?
Yeah, yeah. Sure. Can
Yes,
you hear me?
yes, I can absolutely hear you. And thank you very much, sir. Just to introduce to you, this is the third session of yourself, and to introduce to all my participants about Professor Razi or Professor Islam is that he is an extraordinary scientist in the domain of deep learning and artificial intelligence. So I was very fortunate enough to meet with him in person in his university, that is Bangladesh University of Engineering and Technology, which is the leading university of Bangladesh and doing cutting edge research in the domain of artificial intelligence, data science, cyber security. And to say that Bangladesh is becoming an emerging economy of the world with the visionary leadership, with the highly talented scientific community over there, and extraordinary talent pool over there. Bangladesh is actually catching up with the other nations also in their. Yes, sir. Yeah, yeah. So it's catching up with the quest to develop their own research paradigms and developmental ecosystem. So, to introduce to all my participants, a brief introduction of Professor Alim sir. Sir is basically a professor from the Department of Computer Science and Engineering from Bangladesh University of Engineering and Technology, Dhaka. Sir did his PhD from the Pradi University, and his research interest is wireless networks, embedded systems, modeling and simulation, computer network security, reliability analysis, and deep learning. So these are the broad area. He has done his bachelor's as well as master's, both from Buet, Dhaka. So it's over to you, sir, for your presentation, and he will be basically giving us a very interesting talk on AI for IR, local research, global impact. So this is something very relates to our country as well, because we are also doing our research at our own capabilities to build our own stack of inventions and development in the field of artificial intelligence. So without wasting any further time, I would request Professor Islam sir to deliver his talk, and sir, it's all up to you.
Okay. Thank you, Shofar. So, am I clearly audible?
Yes, sir, you're audible,
Oh,
sir.
great. Great. So, the very first thing I'm liking to be over here is that the faces I'm looking over here in the videos, for example, Rayman, Supratim, and so on, uh, they look like people from Bangladesh because during the pandemic time we had classes with our students in Bangladesh, and the background scenes in the rooms, the beds, tables, curtains, walls, all are same like Bangladesh. I can see Rajasri too. So looks great, looks great. Thank you so much. It's a kind of home-like feeling. And just to relate to you, my own professor at Purdue University, he was an Indian from Chennai. Also, my first neighbor in my lab at Purdue, he was Suresh. He was also from India. So I had a lot of friends. I still have a lot of friends from India. I have collaborators from India who are currently mostly working in the US and so on. So this looks great, kind of home-like feeling. So I'm now sharing my screen. Just please confirm me whether you can see my screen or not. So can you see my screen? Just a blank white screen. Shova.
Yes, sir, we can see now.
Oh, great, 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 great. So first of all, who am I? Because probably I am from a different country, even though we are from the very same region. So just a little bit background, even though Shobha was so kind for having a great background, which I probably don't deserve. But just to have a brief background from me, I'm from Bangladesh, and I have studied for my bachelor's and master's in the Bangladesh University of Engineering and Technology is situated at the heart of Bangladesh, we call BUET. And after that, I went to Purdue in the North America, and I did my PhD from there. And this is the talk I am going to deliver to you. That is AI for 4IR, that is Industrial Revolution 4, local research, global impacts. So we have a very small research group over here, that is Next Generation Computing Group, and I am leading the group. And whatever I am going to show in this presentation from the research perspectives, most of them are done by the students of this research group. So this is a little bit outline of the presentation. First, I'll talk about some background information about the 4IR or Industry 4. Then I'll talk about my early age AI research that I did during my PhD time, with some little bit of my personal stories sharing to you. Then our recent time success stories with AI in our research group, and also which we actually don't hear in the formal presentations, that is the failure cases where we failed with the AI. So I will also talk a bit about the failure cases too. So just to begin with a little background with 4IR, this is a quick glimpse over the industrial revolutions. The industrial revolutions that begin from IR1, then IR2, IR3, and IR4, and probably, at least in Bangladesh, and even in most of the countries over the world, we believe that we are mostly in Industry 3, but we are trying to go to Industry 4, that is over here. And to go over there, we need to understand a fundamental shifting from Industry 1 to Industry 4. So whenever we are gradually going up from Industry 1 to 2 to 3 to 4, there is a subtle thing inherent within the revolutions. That is, when we are going from 1 to 4, the soft part in the revolution is going up, and the hard part of the revolution is probably decreasing a bit. So this is a fundamental nature of revolution of the industries over the past decades. So if we have a brief background of each of the revolutions, the very first revolution is the IR1. That is actually termed as the age of mechanical production, that covered textile, iron industry, steam power, and mechanical tools. Then came the second revolution, that is the technological revolution, that is mostly based on electricity, and that involved steel production, electrification, telecommunication, petroleum, automobile, and so on. After that, we had our third industrial revolution, that is the digital revolution. I believe most of the parts in the world is still in this revolution, that actually encompass the electronic systems, IT systems, and automation. And we can see most of the things, probably many of you are not that familiar, because in the last talk I have heard about the floppy disk 1.44 and megabyte, and you can see the image is over here. That's the second row in the bottom part. These are the floppy disks. I'm not sure whether many of you have seen this or not, but during our student time, we used to use this sort of floppy disk for showing our assignments to our teachers. The next revolution is the fourth industrial revolution, that is related to cyber physical systems. This actually combines the physical world, the digital world, and the biological worlds all together. There are three main concepts of this IR4. First one is the connectivity, then computing and automation. And for Industry 4 revolution, we have four different design principles. The first one is interconnection. That's the most important thing. Then comes information transparency, technological assistance, and decentralization. So these are the very important design principles of fourth industrial revolutions. And we have several pillars of Industry 4. Actually, in many times, it is believed that there are 9 pillars. The pillars are AI, IoT, simulation, big data, cloud computing, augmented reality, with the autonomous system, cybersecurity, and 3D printing. And as you already know, in this presentation, we'll focus on the very first pillar, that is the AI. In addition to these pillars, Industry 4 also have some other key components, and those are blockchain, quantum computing, cryptocurrency, and so on. So why are we focusing on AI? What's the reason behind that? So if we think from two different perspectives, The first one is the service recipients, like ours, when we take services from others, and also the service providers, that is who actually provide the services. Uh, there are two different statistics that are shown over here. The left part is from the customer perspective, that is the service recipient perspective, and the right part, that is the service provider perspective, or the manager perspective. And here, from the perspective of importance of different types of technologies, you can see in both the cases, the second one is AI. And for the case of service recipients, it is very close to the first one. Probably it differs in the first digit after the precision or something like that. And it is 87% of the customers, they think that AI is very important, and the perspective of importance that has been done or explored in the survey. And also from the managerial perspective, they also think that AI is very important. So AI is such a technology that is considered as very, very important from both of the sides, that is service providers and service recipient. And this is why many people are actually doing research on AI. Same to me. During my PhD time, I also did some research on AI. And during my PhD time, I was actually interested regarding the networking perspectives. So, in the networking perspective, there is a concept called RTT, or round trip time. That is the time duration between the initiation of a data transmission from source to destination and the acknowledgement coming back from destination to source. And this difference is called RTT, or round trip time. So estimating this round trip time for a wired network, that is easy. That's okay. But for a wireless network, when there are multiple hops of communication, it's very tricky. So we had a paper, we had a research conducted on this estimation of round trip time using a very lightweight AI technique called Q-learning. And in addition to that, for the congestion control in wireless mesh networks, that is a very prominent research problem back to 10 or 12 years, around 2010 or 12, we had a custom designed neural network that you can see at the left part. And with that custom design neural network, we actually done some sort of intelligent condition control. And in this research, we did our experiments with simulators and with real devices. For example, TeleSB that has been designed and developed from University of Berkeley, and also BeagleBoard. Those are very nice devices 10 to 12 years back. So everything actually went very fine for me during my PhD research. But after finishing my research, I came back to my own country, Bangladesh. And during that time, I had to hear the question, why am I coming back to Bangladesh? So this is a very, very good question that I heard during when I came back in Bangladesh, and also sometimes I still hear the very same question. So this is my personal story, because when I came back to Bangladesh, when someone asked me why am I coming back to Bangladesh, the very first answer I give them with another question: why should not? So in many of the cases, they mention the people, the Bangladeshi people, who are actually residing in North America, they mentioned two different minuses, or two different points that they believe those are enough for not coming back to Bangladesh. The first one is there are many problems in Bangladesh. Here are money problem, we have financial crisis, we have family problem, we have transportation problem, we have health problem, and so on. Probably a heaven place for problems with so many ones in Bangladesh. And the second one, they mentioned that probably, as we are the researchers, probably there are not enough provisions for doing research in Bangladesh. When I heard these two things, these two minus points, I got stuck, because the very first thing I learned from my supervisor, who is Professor Vijay Raghunathan from Chennai, India, that is, finding a research problem is 80% of doing a good research. So when I heard that Bangladesh is a land of full of problems, and again, there are not enough provisions of research, I thought that's a kind of paradox. That should never be happen, because in Bangladesh, as we have so many problems, so this should be the heaven place for doing research. That's why I came back to Bangladesh. And also in conducting modern day research, an important part is doing collaboration. And with the so many progress in communication technologies nowadays, doing collaboration, even from being Bangladesh, it's not a problem, because from our very small research group, we have collaborations with so many universities all over the country, in North America, in Middle East, in Australia, and so on. So that's not a problem. So that's why I came back to my Bangladesh, and after coming back, I started my research over here, first targeting the networking. And the first research relating to AI in networking domain that we actually did in the domain of cognitive radio networks. And probably some of you, if you have already passed the undergrads or you are doing your undergrad studies, you know the cognitive radio networks. An important problem over there is the dynamic spectrum accessing. And for intelligent dynamic spectrum access, we had a new technique, just blending genetic algorithm with local research. And by doing so, we actually try to lessen the interference within the network, and the results were very good. So it's fine. But after coming back in Bangladesh, I thought that networking, probably that's not a very good place for doing research, because in Bangladesh we have a lot of people over here, and if we do some sort of people-centric research, that will be much better. So Shobha, can you hear me? Am I audible?
Sir.
Shobha?
Yes, sir, you're audible, sir.
Oh, great, great, great. So after getting back to Bangladesh, I actually shifted our research focus a bit, and we focused on people. And you know, nowadays, probably all of us has smartphones, if I'm not wrong, 1 or 2 smartphones with us. And a critical research problem back to 5 years or 7 years was how to identify the user of the smartphone. Why is that a problem? Because at the time, we have so many capturing devices like camcorder, drones, and so on. So with these devices, it was proved in the research community that if we only use the password for identifying the user of a smartphone, that can even be captured from around 50 meters distance by using simple camcorder or something like that. So we try to understand why we are actually using the passwords and what are the alternatives. And we have found that there are actually 3 different classical methods. The first one is based on the knowledge that is our password. The second one is hard encrypted devices, and that we can actually process with our keys or something like that. And the third one is our biometric, for example, our fingerprint or our iris, that can even be sensed by the smartphones, and the users can be tracked using the biometrics. So when we compare those things, we have found that for the password, it is not difficult to attack, because if I can just know the password, or even we can just have the hard device that is based on possession, the attack is done. So it is very easy to attack. In the case of biometric, yes, probably it is a bit difficult to attack, but probably you know in recent times there are mechanisms to copy fingerprints, even the iris. And also for the biometric, the devices we are actually using, the devices we are actually integrating within the smartphone, that is not lightweight, and that incurs some more cost. So in our case, in our research, we try to come up with such a mechanism that will be lightweight, that will be very difficult to attack, and that will be cost efficient. So in that case, whatever we targeted, that we don't rely on the knowledge, not possession, not the biometric. Rather, we try to explore how people actually use the smartphone, that is the usage behavior or the usage pattern. So just to show you, for example, you have smartphones and me too, but we all hold our smartphone in different ways. And also we sweep over our smartphone in different ways. Also, we tap our smartphone in different ways. So in our mechanism, we just enable a simple sweep and just a tap. And from that, we try to extract 13 different features: the sweep positions, the sweep velocity, finger pressure, hold time, and rotation metrics. And whatever we have found, that mimicking all the 13 features all together, I mean, the way you are actually giving values for 13 features, if I want to mimic your 13 features values, that is extremely difficult. So we had some real experimentation with so many users, and whatever we have found, that if we are in an idle position, for example, we are standing or sitting, the probability of rejecting the original user, that is quite low. So the identification of the original user, that is okay in a static case, but our main focus was to reject the malicious users. So for identifying whether our approach is good enough or not for rejecting the malicious users, we have done some specific spatial experiments. For example, we had 2 users, user 1 who is the valid user and user 2 who is the malicious user. we let the malicious user, that is user 2, to look at how user 1 or the valid user actually use the smartphone, how he holds the smartphone, how he taps over the smartphone, how he sweeps over the smartphone. And after looking over the usage of user 1, we asked the user 2 to mimic the usage, and he could not do anything, and the success rate was completely 0%. Then we asked the valid user to train up the malicious user, so that the malicious user can understand how the valid user, that is user 1, actually holds the phone and swipe over there and tap over there. And after this training, we have found that, okay, just after the training, the malicious user can get a success rate of around at most 40%. After 2 hours, we again ask the malicious user to mimic the same thing again, and we have found that the malicious user could not have any success after 2 hours. So it is near to impossible to memorize how other people actually use the smartphone, how they hold the device, how they sweep, how they tap. So we have found that this is extremely difficult to attack, and we actually propose this technique for very sensitive information. For example, in North America, we have social security number, and all over the world, we have very sensitive banking information, health information, our credentials, and those could be saved by this sort of ways. So what is the basis of this scheme? The basis of this approach? The basis of this approach is a clustering method, and I have heard that at the end of the previous talk, you talked about differences between classification and clustering, and this work actually leverages a new notion of clustering that we termed as mean SG clustering. That is very simple. We actually had a cluster size that is a weighted average of average and standard deviation, and that's it. And you can see this is a cluster and this is a cluster. And in this way, we actually identify different users of a smartphone. Using the very same thing, we try to go beyond. And while going beyond, we went from smartphone to firearms. And in case of firearms, it is very, very important to identify the actual user of the firearms. Why is that important? We have found that all over the world, there are a number of casualties for misuse of firearms. And most shockingly, the number of these sort of casualties is going up over the years. And another shocking part is that in most of the cases, the children are the victims of this sort of misuses of firearms. So we need some mechanisms to ensure that the actual users of the firearms are using the firearms. So for this purpose, we have tried to identify what are the different number of casualties all over the world, and we have found that you can see most of the casualties, they are actually happening in Asia and Africa. So most of these casualties actually involve low and middle income countries. So the solution that we need to have for this purpose, that should be low cost. But when we looked in the literature, we have found that there are some solutions for this problem, but they actually use a number of sensors, and that's why they are costly. They are expensive and they demand high energy consumption. So we try to have a new solution that will take a very small number of sensor, very low cost sensor, and that will not take so much of energy consumption. And from that perspective, we had a professional army person with us, and we try to identify what are the parts of the palm that actually exert the most pressures over the firearm. And we use a very low cost pressure sensing sensor. You can see that in the right hand side, the top part. And with the pressure sensing sensor, we identified that there are actually 5 different places at the palm of a soldier that exerts the most pressure over the firearms during its operation. So we put 5 different sensors. You can see that this is a prototype firearm, and with this prototype firearm, we had 5 different sensors placed at that 5 different parts where user actually exerts pressure, and the pattern of exerting the pressure that actually differ user to user at 5 different places. So we took the pressures, we have the clustering using our newly proposed mean SD clustering, and after that we identify the users. So this was very interesting, and we evaluated this solution with so many users, real users who are actually working in defense and so on. So after that one, what we targeted that if we can use the mean SD clustering for the purpose of user identification, can we go beyond that? Can we try to identify some sort of traits of or characteristics of the users? In that case, we targeted that whether we can actually identify the emotions of the users. So in the case of identifying emotions of the class users, we try to first induce the emotion, because emotion identification or emotion classification, that's a very, very difficult problem in the literature. The very first challenge over here is to understand in which emotion user is right now. So that's why, to make sure that we are actually having a defined state of emotion, we induce emotion over users. For inducing emotion, we actually used different types of videos, and the very middle part, that is that video from Mr. Bean. And we know if a user actually see the video of Mr. Bean, in what emotional state he or she should be. So there are several different videos. Those are very famous in YouTube, and also in different social media, and also in different TV channels. We took those videos and we show the videos to the users so that we can induce emotion over there. For the purpose of classifying the emotions, we identified that there are 10 different classes of emotions, in which can be categorized in 3 different categories. The first one is the dominant emotion. Those are amusement, surprise, sadness, and anger. The next one is less dominant. This type has 5 different emotional states: happiness, inspiration, sympathy, disgust, and fear. And beside this dominant and less dominant emotions, we have neutral emotional state. So when we actually impose or induce these emotional states, we had some sort of survey from the users, and when they participated in the survey, we actually collected different types of usage behaviors from them. For example, how they used the mouse, how they do the left click or right click or scrolling or double click, and also how they use the keyboards, how many times they push the backspace, the enter button, and what's the dwelling time. There are 17 different attributes that we collected in this way in every 5 seconds. And after that, based on these keyboard and mouse usage attributes, we try to relate them with the different emotional states that we induced over them. And when we actually employ some classical machine learning techniques along with our classification technique, we have found that for identifying the 10 classes of emotions and 2 classes of emotions, the classical ones are very nice up to the dominant emotions. But when we try to identify or classify the less dominant 5 emotions, our proposed classification technique, that is the mean SD clustering, the clustering technique that we actually proposed, that achieved the highest accuracies over here. So after doing the emotion classification, the next target in our research group was to identify lying, because in our natural life, we can each and then we can find that people say true statements and also lie statements. But in the case of lying, many times it is very difficult for us to understand whether a person is lying or not. So what we try to do, we try to classify the lie statements using smartphones. And the thought process is like that. Using smartphone, we can actually capture different features, for example, typing speed, acceleration, touch pressure, and so on. And for the purpose of data collection, we actually we developed an app, and we put there some sensitive and non-sensitive questions from the literature and from the blogs. We have understood what are the sensitive questions where people generally lie. So in our survey, we put those type of sensitive questions, and most of the times we know that those answers are lies. And during that time, we captured these features that we have mentioned over here, for example, typing speed or shaking or something like that. So why did we actually capture these sort of features? Just I am showing you two examples over here. You can see that these are the data for different users, around 42 users. And you can see that for typing speed, only for a couple of cases, at the false statements or at the false replies, the typing speeds are higher. But for the rest of the 40 users, when we actually state true statements, the typing speed is higher. And for the case of average shaking of the mobile, we found that when we have some sort of false replies, the shaking speeds actually goes up. Only for a couple of exceptions, this goes the other way. So we have found that for different features, there are some relations between the feature values and the state, that is whether we are putting true responses or false responses. So this was very encouraging for us, and we actually used our collected data set with different types of classical machine learning techniques, for example, random committee, random tree, and random forest. And you can see that with those, we can go over around 80% accuracy. And the best one was random forest. We try to go even beyond this one. We try to go above 90% accuracy. And for that purpose, we had to utilize a new technique called NMR. That is not actually a new technique. That is actually used in fault tolerant cases in many system development. That is called N-modular redundancy. In that case, we actually combine different classifiers all together, and our accuracy actually went up to 94%. So this was our work related to lying, people lying. The lying is a kind of negative activity, and another negative activity in the cyber world is cyberbullying. And that is prominent all over the world, not in only in Bangladesh, not only in India, but also in North America too. And you can see statistics over here in a school of North America, and you can see many people over there, even the children are victims of cyberbullying. So what are the classical approaches of detecting cyberbullying? For example, in the case of Facebook or Instagram, they were mostly relying on manual reporting by social media users. But the problem is that that depends on willingness, and it was not always comfortable for the users to report about cyberbullying. The next automated part is based on text analysis, but the problem is all over the world, we have more than 6,500 languages. And also the abusive word set extraction, that is extremely difficult. So if we rely on language, then we need to have some different solutions for different languages. And you see the number of languages, those are thousands, so it is near to impossible. So in our research group, we try to understand whether there is anything common all over the world. For example, a user from Bangladesh, a user from India, a user from North America, all have the same thing. Is there anything like that? And we have understood that yes, there is one thing, and that is our face. So whenever we have some sort of interaction in any social media, we must have some sort of facial expressions. And if we could capture the facial expression during our activities, and to do so, we actually developed our own application that actually indulges the cyberbullying in our survey or in our developed application. And during the cyberbullying, and also not doing cyberbullying, we captured the facial images of the user. And after that, we have some sort of image processing over the facial expressions, and we took actually 6 different points over the face of a user. The 2 points at the 2 different corners of our eyebrow, the another 2 points are 2 different corners of our nose, and the last 2 points are 2 different corners of our mouth. There could be different distance measures over these 6 points, but after our rigorous experimentation, we have found that there are 4 different distances that you can see over here, the green lines. This is the left part, that is from eyebrow to our mouth. Similar happens to right part, and also another one is from mouth to our nose. These 4 distances, those actually get changed substantially when we do some sort of cyberbullying. And you can see that for same person, if we collect data with the accuracy of around 99%, in some other cases, we can say that whether the user is cyberbullying or not. And even the data collected from other users, we can understand with around 70% accuracy whether another user is cyberbullying or not, based on these 4 different distance measures over the facial images. So after doing this sort of work, we also try to do some sort of work related to languages, because in Bangladesh, we actually talk with Bangla, and many parts of India, you also talk in Bangla. But in Bangla, back to 5 or 7 years, the natural language processing was not prominent. And at that time, we also had some sort of work related to AI in the case of NLP. And our target was to have some sort of translation work from Bengali to English, because many people from Bangladesh and also from India, Bengali speaking people, they travel from India and Bangladesh to many other parts all over the world. So we need to have some sort of machine translators, but the popular machine translators, those are not very enough for low resource languages such as Bangla. So we try to have some sort of solution for Bangla to English translation, because if we could translate Bangla to English in many of the parts, for most of our people who travel from Bangladesh or from India to other parts of the world, that will make their life very easy. And we have found that in the literature at that time, we had two different types of translators. One is data driven, based on the machine learning, and another one is rule-based translator. So in our study, we try to explore whether we can blend these two different types of translators. For the blending purpose of these translators, we had three different ideas. The first one is first to employ the neural machine translator, that is the data-driven or machine learning-based translator, and then we correct the output of the NMT or neural machine translator with a rule-based translator. The next blending approach is just the reversed one. First, we have a translator based on the rule-based one, and then we'll correct the output of that translation using an NMT. And another blending approach was just to have parallel translator with both, and based on the type of sentences, whether that is compound sentence or complex sentence or simple sentence, we'll take one of them. So when we actually experimented with some data sets, we have found that the best one is the NMT followed by the rule-based translator. So why is that? Why we actually find the NMT followed by rule-based translator the best one? To explore that, we actually try to understand what people actually do during the translator time. For example, when I went from Bangladesh to USA for my PhD study, at the very beginning of my staying in USA, I had my translator in my head. And there was a process in my head how I actually translated my sentences from Bangla to English and then communicated with the North American people. So we actually surveyed over many people to understand how do they actually translate at their real life, because we believe that humans are the best translators. They are much better than machines. So what approach is actually followed by the human translators? And we have found that most part of the translations done by the human beings, that is done based on their experience, that is based on their data or based on their learning, and they correct the translation by rules. So in real life, we people actually do the data-driven translation first, and then we correct the output of the data-driven translator by rules. So this is the very same thing we have found in our research study. In the case of machine translation, if we follow the very same approach or very same sequence, we get the highest accuracy in the machine translation. So this was very encouraging for us, and we actually grounded up our results from the behavior of general people. So up to this point, we have talked about people and some applications or traits or characteristics with the people. Now I'll talk about a bit about some applications involving people and some sensitive applications. For example, a sensitive application is human counting in many of the places, and you know we can count human with the cameras, but the problem is that camera can see us and we can see the camera too. So in the case of intruders, they can just simply damage the camera or image capturing devices, and this happens because they are visible. So this sort of problem is very prominent in case of very sensitive infrastructures, for example armory or bank vault, because you know the sensitivity of the storage is over there, because in the armory we store our arms, and in the bank vault we store a lot of money over there. So we need to have some sort of human sensing and human counting over there that is resilient from the attacks by the intruders. So we try to understand, is there any way to count people or to sense people with a device that is not visible to us? So we understood that yes, that should be an approach in that way, because when we enter a room, we actually change the concentration of the gas or the air over there. So if we can just sense the concentration of gases in the air, then probably we can identify whether a people has entered over there, or a person has left from the room. For that purpose, we actually developed this device, and thanks to our Ministry of Education, because this device was pretty costly and we had to purchase a number of gas sensors from North America during our work for this purpose. And we actually had different sensors for sensing carbon monoxide, carbon dioxide, nitrogen dioxide, sulfur dioxide, ozone, LPG, temperature, and humidity all together from this device. And this is our custom built device. And with this device, we actually collected data from different types of room settings. And you can see there are 3 different room settings. And we collected a lot of data, and we actually give the collected data to different machine learning classifiers. And at the first time, we had an intuition that probably with the sequential classifier that actually takes the sequential changes into account, that should be a better one to explore for this purpose of human counting based on the gaseous changes within the room. Because we thought that with the progression of time, if the number of persons within a room changes, probably the concentration of gases, those are related over the period of time. But we are actually wrong. And we have found that the sequential classifier, the performance was not that great. But for the non-sequential classifiers, we actually take the data points individually, we got a very good accuracies. And you can see from more than 80% accuracies to near perfect accuracies. So this was our work relating to human counting. That was a kind of very sensitive application. In addition to that, we had another very sensitive application that is very relevant to our country and also your country, because the problem is real, and that problem actually relates to our transportation over railways. And you know, in many of the times in our railways, we have some sort of missing rail box, and for those reasons, we had derailments of trains. That actually incurs a lot of death tolls and losses from financial perspectives too. And you can see the top right part, that is an image taken from Bihar, India. And this sort of images are prevalent in Bangladesh, in India, and many countries in Africa. For example, Congo, you can see the image in the left bottom part, that is from Congo. And you can see the statistics from Bangladesh. The number of these sort of events is substantial. So we need to have some sort of measures for this, because around 92% of these accidents in Bangladesh actually occur due to derailments. And we have found that an automated system is needed for detecting this sort of problems, because in many of the times the cause behind this problem actually happened before a train ran. So in many of the countries, we had some sort of problem, but those are non-real time. But in our case, for example, in Bangladesh or in India, we need to have some sort of real-time solution. And for the purpose of having a real-time solution, we have a system model, and we actually deploy some sensors in the rail track. And also we have another set of sensors in an approaching train. And whenever there occurs some sort of problem in a fish plate or clip or anywhere over the rail track, then that will be sensed. The signal will be transmitted to an approaching train, and that can stop after having that signal. So for this system model, we have different types of research challenges. The very first challenge is the sensing part. We need to sense whether a train is coming, whether the rail line is continuous or not. And for that purpose, we actually build up a sensing module from our research group, and this is the sensing module. And for the first time, we could achieve up to around 4,100 meter distance sensing range with the notion of edge ML. And with the edge ML, actually we scaled up the distance even more. And in the progression of our research, we have found that deploying only one sensor is not enough. We need to have multitude of sensors. And you can see we have a number of sensors over here, and we actually take sensed values all from the sensors and compare all those values, and then make the decision whether a train is approaching, whether the line is okay, and so on. And you can see the students from our research group, they had real experimentations over the railways. And one of the students from our research group working in this research problem actually went to Bangalore, India for doing his job in Microsoft Research, and after that he actually moved to Redmond, USA. And we have continuous collaboration with him, and from him we actually have some sort of ideas about the cutting edge development of edge ML in Microsoft Research, and we try to deploy those things in our research. And you can see the deployment, and this is the device we developed from our own research group for the purpose of the sensing. And we experimented at different diversified scenarios. For example, when the rail line is completely free, when people are walking beside the rail line, when another road is crossing across the rail line and other vehicles are there. So there are so many cases we experimented in real with this sort of sensors that we developed from our research group. And we try to deploy some sort of soft part too after deploying the HML. This is the prominent part of the HML, is that we deployed bonsai along with some moving averages over our sensor values. And you can see when we deploy our moving average, the green line, we got a very high accuracy in our sensing. And for the case of bonsai, you can see that the accuracy is very high, but the memory usage is very low. Why the memory usage is important? Because when you deploy this sort of sensing devices over the rail lines, we can deploy with some sort of very small microcontrollers, which has very small amount of memory. So for the other cases, for example, nearest neighbors or distant tree, you can see the memory usage is pretty high. But in the case of bonsai, the memory usage is very low, but even the test accuracy, that is very good enough for our purpose. So this was related to our work in rail line. Not only rail line, in the case of transportation, we also had some other work, because you know in Bangladesh, a well-known problem is traffic jam. And if I'm not wrong, in India too, in many parts of India, you also experience the traffic jam. So in the case of traffic jam in Bangladesh, this is very prominent problem. How prominent is that? In Bangladesh, the average public transport speed is around 7 km per hour, which is expected to be 4 km per hour within the next 10 to 12 years, which is slower than walking. And what is the ultimate consequence? It was around 3.2 million working hour daily and billions of dollars. A research study from Buet that has already said that around 60% of these losses can be recovered by adequate traffic management and efficient policy making. So for the purpose of efficient traffic management, one of the key part is managing the traffic at the junctions. So at the junctions, for the existing solutions is that we need to optimize the signal timing based on the current vehicular density. And for that purpose, we have different image-based deep learning techniques, for example, YOLO or SED and so on. And the classical part is that we capture the traffic images from the road, then we send the images to a central server, and then in the central server, we take the decision. But the problem is that when you send the images, that demands high speed network connectivity that is not probably available for many developing countries, including Bangladesh, India, Kenya, and so on. So we move to another system model. In that system model, we actually capture the images on road, and then from those images, we count the vehicle on road, and we send only that count. And the count, that is a kind of text data, very small part, that actually being sent to the central station, and the optimization is done over there. So it's a kind of decentralized technique. And you know, when we try to do that, we have to do the deep learning part or machine learning part in the embedded systems, because they are deployed over road, and that imposes severe computational constraint on the deep learning or machine learning architectures. So this is a kind of unique problem for our cases, for example, Bangladesh and India, and that's why we propose a new solution over here, thanks to our ICT division. And we actually had a lot of data collections from our real road and some other existing data sets. We train up those using GeForce machine. That's a high-end machine, but we test that with Raspberry Pi, and you can see the results over here. You can see the DhakaNet, that is our proposed one, that has lower error and also lower time needed for the computation. That means it is much faster. And also, if we scale up, if we scale down the whole model, even then the accuracy is higher and the speed is also higher. So this is a unique solution proposed by our research group, and that has been published in ICDM in the last year. That is the topmost conference in the area of data mining. And we not only tested that in the laboratory, we also tested that at real over a road of Dhaka. And you can see this is the road of Dhaka that we say the place is named as Tezgao. And we implemented our device over there, and using the Raspberry Pi, we uploaded the images to cloud. And these are the real-time images that was actually visible over our developed solution. And we can see what are the densities of vehicles over the road at real time. So we actually counted the vehicles on road in this work, and in another of our work, not the vehicle, we try to count and localize the people, and that is related to a Muslim congregation called Hajj. And you know, during the COVID period of time in Makkah, that is a Saudi Arabia, the Hajj actually had a very small number of people, but in reality, and also now the Hajj actually has millions of peoples in Makkah. And if I am not wrong, you in India also have similar type of congregations, for example, the Kumbh Mela, if I'm not wrong. So in this sort of mass gathering, it is very important to have tracking of the count of people and their locations. And for this purpose, we have already understood that in the place of Makkah, we have a number of cameras, and we could use that for counting and localizing. So for the purpose of counting and localizing, based on the images captured by those cameras, we developed a new solution, a new deep learning model with a special type of delicate blending of self-attention within custom deep learning architecture. We actually deployed that with the over the images collected from the Hajj, and you can see the red dots and green dots. Those are the localized positions of different people over the images, and these are done by our own developed deep learning models. So up to now, we have shown you some success stories or success scenarios from our research group. But what about the failure cases in formal presentations? It is very rare to show some sort of failure cases, but I will try to show you a couple of failure cases. Because in our research group, we also do some sort of research on the network security that Shobha has already said. And probably you know about the RFID and NFC that actually communicate within a very short distance, like millimeter or something like that. And in that short distance, it is commonly believed that they are mostly secured. But in our research group, we showed that even a very critical type of attack called man-in-the-middle attack, that is this card and reader, these are very close to each other, for example, within some millimeters, but we can place an attacker even in between them, and we can change the data from the card and feed the changed data to the reader. So we did that with some sort of real experimentation, and this is our real setup. And after doing the MITM, a new type of attack, when you devise this sort of attack, it is then become our responsibility to have some sort of safeguards for this sort of newly devised attacks. So we try to have some sort of safeguards or countermeasures for the attack, and we try to understand whether there are any patterns in the signals during the legitimate connection and during the attacked connection, and can we do some sort of identification based on the signals captured. And these are the signals. You can see that the green one is the normal transaction, and the red one, that is kind of attack scenario. And we deployed around 30 different machine learning classifiers, and we can see that the machine learning classifiers can't achieve even 60% accuracy in identifying whether there is an attack or not. So that's a type of problem, and this is a kind of failure case. Another failure case in our research group we have faced, that is regarding earthquake prediction. And you probably, many of you know, there are different satellites now all over the world. They're circumventing the world. They're circulating over here. And one of the open satellite, that is the GRACE satellite, we collected data from the data collected by the GRACE satellite, and we try to understand whether deploying machine learning techniques over the data collected by the GRACE satellite from the perspective of gradients, can we predict earthquakes? And in the case of our prediction task, we have identified that the machine learning techniques, those probably don't have that much promise, because they don't have good accuracy in predicting earthquakes. So these are two failure cases. I am near the end of my presentation. This is the very last slide. This is a little bit of advertisement. So in our department from our university, we actually organize a specialized conference on networking systems and security. And probably in the subcontinent, this is only the specialized conference on networking systems and security. And in 2022, at the end of this year, this is planned to happen in Cox's Bazar. Probably that's the largest sandy beach all over the world, a very nice place. So this is a simple call for papers, probably that has another 1 or 2 weeks ahead for the submission deadlines. And if you do have any research submissions planned ahead, please consider this venue as a potential submission venue for your papers. And last but not the least, please always feel free to have a critique to my work. And I always treat the people who has some sort of critique to my work as my best friends. So if you have any sort of questions, queries, comments, suggestions, anything, always feel free to email me. Thank you so much.
Sir, Rajashri has got a question for you.
Yeah, just a second. I'm going over there. Yeah, so related to cybersecurity, forensic science. I also, but is there any idea to simplify the process of photo spy post-mortem examination of dead body, as it takes a long time to be done and the investigation becomes slow due to the problem? Can we use this AI and Apple sensor to extract primary information before the actual auto spy? That's a great question. So Rajeshri, thanks for the question. Actually, in our research group, we have a kind of parallel focus on computational criminology. Probably many of you know about the notion of computational criminology. So there are criminal science, and in the case of criminal science, there are a lot of data, and we try to actually use those sort of data for some sort of future prediction. And whatever you have mentioned over here regarding auto spy, so the dead body, uh, those dead bodies have several information inbuilt with them in many of the cases if there is something wrong with that. So if we could have some sort of sensing over there, definitely we can have some sort of intelligent learning over there for predicting what happened to that one. So I guess, yeah, for auto spy, we can definitely do some sort of research work in that way. And from my own experience, I have understood that deploying sensors, different type of sensors, it's not always good, because when you try to deploy different types of sensors, it actually increase the challenge and complexity of your work. So we need to minimize the number of sensors. Why I am saying that? For the purpose of auto spy, probably deploying more sensors is worse than deploying only the camera. You can just take images, and if you have a lot of images of the dead bodies, you can use that in your learning, and in future you can do some sort of prediction based on the learning you have got from the images. But here comes the challenge: how can you get that many images? So in the case of computational criminology, this is a very classical problem, at least in the part we are actually living in the third world countries or in the subcontinent part. Because if you search on the web, you can find data related to criminology for North America, because they are taking or capturing this sort of data years back. But in the case of India or in the case of Bangladesh, this sort of structured data, probably those are not available. So if we want to do this sort of research, the very first challenge we need to face is the data collection part, is the data set preparation part. So we need to have some sort of very good connection with the hospitals and also the law enforcing agencies, and then we need to capture the images of the dead bodies. And when we have a good number of images, when we have a good volume of data set, only then we can try for a good learning and then for prediction and so on. So Rajeshri, have you got your answer?
Yes, sir. Yes, sir. I got it. Thank you, sir.
Thank you so much. Thank you.
Sir, with respect to this, I just have one question. Like, can we use like representation learning kind of algorithm architecture for where we have less number of images? So can be used in this particular scenarios?
Yeah,
It,
yeah. Please go on. Please go on.
yes, that was my question. Like why we don't have, because medical images are universally, not only with respect to autopsy, but also with respect to like cancer detection, several cancer detection. So there is basically the lack of images, and from my personal experiences, what I found out is that those hospitals who are having the repository of images, they also don't share those images with the outside authorities. So in such cases, can we just do the feature extractions? And so suppose we have image data set of say Western countries. So can we do work with some image represent feature extractions and do a working with the feature extraction and doing with that as a representation learning? So that is my question, sir.
Yeah, that's a great question. Representation learning or transfer learning, these are the techniques that can always be explored for this sort of problem where the data volume is less. And in the case of autopsy, yes, that could be explored, but I am a bit skeptical about the success of those notions in the case of autopsy, because the nature of this problem, that is probably fundamentally different in other cases. For example, in the case of diseased people, the way a human body gets changed, and the way in the case of crime, experiencing crime, a human body actually gets changed, those are fundamentally different. So in the case of transfer learning, if there is a coherent relationships or some sort of similarities between what has been learned and what is being explored, then the success is probably much higher. But in the case of this sort of problem, for example, autopsy, whatever images we have, probably they are fundamentally different. So that's why probably I'm a bit skeptical, but after experimentations, we can actually understand how far we can get the success. But that's a very good question.
Yes, sir. So, any other questions from the participants? Because Sad has
Excuse me.
shared.
Uh,
Yeah,
uh,
please, Rahul.
can I ask the query from Professor Razi?
Yes,
Please,
absolutely,
please,
Rahul.
please go on.
Okay, Professor Razi, good morning. First of all, I must thank you for such a very knowledgeable presentation in which you have shown about the research activities carried out in Bangladesh, despite you had the offer to serve in the US after graduating, rather doing the PhD from Purdue University. I just learned that you have done something in the railway track using some sensors, which you bought it from one person who worked in Bangalore. And seeing the accidents which you have shown in the pictures, there were three pictures which you have shown. One was Bangladesh in 2012, one accident of derailment. Second was in Bihar in 2019, and third was in Kenya, I guess. And you mentioned that these many rail networks, you have put some sensor to prevent these kind of incidents. So first of all, I just found out the data. Like in India, we have around 1 lakh kilometers of railway network. Vis-a-vis in Bangladesh, at a very early stage, it started considering the safety matters, despite having only 4,000 kilometers of railway network in Bangladesh. And still you are able to analyze the problem, because 80% of the research which you mentioned that can be is basically finding the problem and analyzing the model. So my query is that once you have done the part of analyzing the situation, that what kind of sensor you're using, because what I could understand from the derailment part, that can happen due to the mechanical track failures or broken rails, or like some kind of conductor error. But you have mentioned that missing rails. Missing rails, do you mean that the rails, the tracks got missing, or is it the any reasons? And all these sensors, are they able to find out, rather the sense the problem within the rail track or within the wheels also? Because there are certain reasons in which the wheels also cause the derailment. So if you can just throw a little light on that, so that we can also try to give some inputs, because I belong to IIT Kanpur only. So that's a very good research topic which you have given us a hint.
Oh, great question, Rahul. Thank you so much for the question. So enlightening. First of all, let me narrow down our scope. So whatever we are doing is completely based on rail tracks, nothing related to wheels. This is the very first thing. So there are problems with the wheels, and that can cause rail derailments. Yes, you are pretty correct. In the case of Bangladesh, I don't have the statistics of India, but in the case of Bangladesh, most of the derailments are due to for the problem within the rail tracks. So that is our prime focus. This is first. And second is that you talked about the range of sensing or something like that, right? And also you talked about whether that only is applicable for the missing rails. That's not. If there is any problem within the rail line, fish plate, or clip, anything else that makes discontinuity within the rail track, then our system will work. And the sensing range is around 1 kilometer now as per our current work. And the interesting thing is that when I am actually present in this talk, my research group, 4 to 5 people, they are actually collecting data over the railway in Dhaka. So it's a kind of continuous work. So at the very beginning, we had a sensing range of around 80 meter. Then we went up to 200 meter, then 400 meter. Now we extended that to up to around 1000 meter. And in your question, I got another hint of question. That is, you have a lakhs of rail lines, probably more than lakh of meters of or kilometers of rail line. In Bangladesh is thousands kilometers of rail lines. So from our perspective, it's not always feasible to deploy these sort of sensors all over the rail lines. So that is another research problem. And one of our master's student, he actually completed his master's over here over this research problem. And after finishing his master's, he went a couple of months back to Arizona State University for his PhD. And his research problem is to optimize the deployment of the sensors so that we can get a good trade-off between costing and minimizing the vulnerabilities. So even though we have thousands of kilometers or lakhs of kilometers of rail lines, we are not proposing to deploy the sensors all over the rail lines. So there are some vulnerable parts from the historical data where the rail derailments mostly occur, and we identify those and we propose to deploy the sensor nodes apart 1 kilometer from the neighbors, so that will not cost too much. And that is probably the optimized case of deployment, whatever rail lines or whatever length of rail tracks we have, either in Bangladesh or in India. So Rahul, have I answered your question?
Yes, sir, you have answered my question, sir. But now, since you have mentioned that your sensor working to just find out something related to the connecting, rather the continuity of the rail tracks. So, but it may happen that there is a track misalignment without addressing or without compromising on the continuity part of the rail tracks. Still the trains get derailed. So you have focused on the one particular part in which we can understand either the train tracks are missing, rail tracks are missing, or there is some kind of a discontinuity or some kind of a failure of the material. Those things will be addressed by your research, but there are other reasons for the derailment also, which are the which can be explored to do the research and what you mentioned, that we should have the optimization in terms of the cost effectiveness of deploying all these sensors all over the country where the rail networks are, because we belong to the fifth largest, rather fourth largest in terms of the rail network in all over the world. So my only the query was, how do we find a solution to the Indian continent, basically? So thank you so much for giving the input, sir.
Yeah, great. So Rahul, your supplementary question, that is probably even much better, because you talked about the cracks over the rail. Am I right, Rahul?
Yeah, basically it's all synonyms. We always talk about that. Some people say track, some people talks about the rail, but basically what I've understood, that
No,
whatever solution you've given.
Crack.
Yeah.
You talked about cracks over the rail line, right? That also causes the derailment. Am I right?
Yes, sir. I was talking about the tracks only. Because I mentioned that once these tracks are not even properly aligned during the beginning stage of the laying the rail lines, rather laying railway tracks. So at that time also we have to see the material quality, and wherever the manufacturing units are employed, that the quality check should be done. For that only we have these compliance standards, even now in these railway tracks also.
Agreed. And even with the compliance check, there could be some cracks, and over the period of time that can happen. So the answer is, we still do not know whether our approach is enough or not, because collecting data over the cracks, that is kind of near to impossible to us till now, because we don't know where are cracks.
Absolutely.
But if we deploy the solution, and in that case, in some cases we have got some sort of red alarms, and then we find everything is okay, then we can probably understand whether there is a crack or not. So for answering your question, probably we need to wait a bit more after the deployment, because we are yet to find any real cases where we can have some sort of data collections with the rail lines with cracks. So still it is great to us, but that's a great question.
Thank you, sir. Thank you so much.
Mhm.
I think so. This the solution which you have spoken about, spoken about the railway tracks. That the same solution also is very much can be applied with the metro rail system as well. Because one of the problem with respect to Kolkata Metro Railway is that basically Kolkata Metro Railway is susceptible to lot of suicide cases. So like you had basically checking with respect to the train. So your problem is basically focusing on train, approaching the train, but also like when basically there is when the people are standing on the platform of the metro railways, so the simplest kind of sensors can also be applied along with the image processing also to prevent such kind of suicidal cases. So there are a lot of there are a lot of subsets of problems which can be solved from one problem. So a technology which can be developed from one problem may find solution to many subsets of problem with a similar kind of of similar kind of issues which they are dealing with. So that is one thing I think that so this gives us a lot of opportunity, especially your research group has worked on a multiple dimensions of innovations in the domain of what they call artificial intelligence. So basically, with respect to image processing, natural language processing, and I was really fascinated the way you have spoken about the NMT plus rule-based translation system for the natural language processing. So similar kind of natural language processing approach with respect to Bengali language. We also tried to develop a kind of a software that was basically an AI-based conversational system. So that was also the first of its kind with respect to Bengali language. So I think this kind of vernacular language also had a lot of potential. So your model, and we know like similarly like a lot of immigrants you are talking about who are coming to Dhaka or elsewhere who doesn't have a knowledge of English. The similar problem we also face when we go to countries like Japan or other countries where that much English is not used. So your solution is also providing us a good platform in this particular regard. So yeah, so Rajesh again asked a question like, can we use thermal imaging to find the cracks in the railway tracks, sir?
Yeah, I was seeing the question and I was waiting for you because you also mentioned about the image processing, right?
Absolutely,
Regarding
sir.
the very problem. And the interesting thing is that we had several masters and PhDs on this very same research. And in one of the master's defense, the student was asked the very same question. Why is this solution? Why not only image processing or even better, the thermal image processing as Rajeshri has already asked? A great question. The thing is that uh, in the case of real-time processing, if we try to have thermal imaging and we plan to hold the thermal image capturing camera within the rail within the approaching train, what should be the coverage of that? Can you think of capturing 1 kilometer away thermal image with a camera and identify whether there is a continuity of rail line or not? Probably that's not the reality. And if we think that we'll deploy the thermal image cameras or any other cameras all over the line, you can understand the cost, right? So there is the trade-off. How we can extend our sensing range and even we can limit the cost of the deployment. From that perspective, the solution of image capturing or thermal imaging and so on, those are probably getting ruled out. So Rajeshri, have I answered your question?
Yes, sir. Yes, sir.
Right.
So I think you have given us a lot of knowledge food to explore different areas of the budding AI enthusiast. So basically, we are also trying to work under you for the problem, which is basically the network intrusion problem. So, especially Rajashri, Supratim, Anushree, they are all the part of this particular project. We'll be working on that. So, yes, so area in the domain of artificial intelligence. So if anyone is having any further question before we can wrap up the session, because it's already 2 p.m. at Dhaka. I think Sir must be having lunch also.
And
Uh,
that's fine. That's fine. The same lunch time in India is
yes,
Bangladesh. So it's very simple.
absolutely.
Just half an hour. That's fine.
Yeah. So yeah. So any further question from any participants over here? So basically, just to sum it up today's session, I am lack of words to thank Professor Islam for his exceptional talk. Basically, it was more of like a, ideas sharing session. So it was a great indeed interactive session, gives sharing his ideas, his research achievements, and he has also given the participants a great opportunity to present if there some of them is having some research paper in the conference. And obviously the location itself is Cox's Bazar, so that itself is a great place to visit in Bangladesh. So eventually we'll also try to send one of a paper over there. So that is the thing, and we are really indeed grateful to you, sir. And I hope the students, the true AI enthusiasts, will be in touch with you. And as far as our organization, so if anyone is interested to discuss about any potential research collaboration, research activities with us, then I am also available to talk with you in this particular domain. I just share my email ID and my phone number for your reference across the two countries, both Bangladesh and India. Uh, Anyone is interested to talk with us about pursuing a research, you can please get in touch with me. So I this is basically my email ID, and this is my phone number. People from Bangladesh can add 0091 prefix before my phone number, and this is my email ID. So that is from my side, and you can take a note of it if you are just seeing my screen. And my honest thanks to sir, and we will be in touch with you, sir, for future research ideas, sharing collaborations with you, and undertaking key research problems under your esteemed guidance. Uh,
Thank you so much. Thank you so much for inviting me. And this is the very first time I got a chance to share our research work in an event hosted in India, because I had this sort of opportunities for Canada, US, and Bangladesh definitely. But for the India, it's the very first time. And I'm very happy to see your in-house faces and in-house backgrounds. And those are very, very charming to us because that look very similar to my own country. Thank you so much. Have a great day. And
thank you,
I
sir.
think I can take a leave right now, right? So,
Yeah,
last of all, if you would have any sort of critique or comment, always feel free to email me, please.
absolutely, sir.
Thank
Absolutely.
you so much.
So yes, sir. Thank you
Bye.
very much, sir. Thank you very much for your precious time.
Bye.
Thank you. Yeah. So, yeah. So, this brings us to the end of our third session. And I really thank all the participants who have seriously participated in this particular webinar. Lot of people would have now lot of ideas related to artificial intelligence, governed AI, statistical applications on the scenario of artificial intelligence. So, lot of things we have learned within 3 hours of time. So this is the basically this is basically the idea behind getting into the challenges of learning artificial intelligence, really doing something uh, applicable to AI. So once again, I thank you all for joining us today on the eve of our 75th Independence Day. Thank you all. Have a great day ahead. Enjoy your day with your friends and family. thank you for giving your time and patience to be with us to learn from our professors, our extremely, and we'll be holding our next webinar again on the 15th of August 2023, uh, approximately with all the professors who are there today, and obviously some new scientists in the emerging areas of artificial intelligence also will be joining us in the coming. And if you have anything to know from us, as an organization, we are also working in the domain of AI, data science, explainable AI. So these are even the supply chain analytics, cyber security, along with Professor Razi. So these are the areas we are also working in this domain. So you can check out our website, and if you're interested to do some kind of research with us, please feel free to be with us. I am available along with my team. And again, wishing you all a great, happy Independence Day. Thank you very much. I am signing off for the day. Thank you very much.
Thank you, sir.
Thank
Thank
you.
you, sir. Thank you, sir.